by Kaylee as well from the NHS-R community today. So thank you. There we go. Recording started. Okay, so welcome to this course. Hi to the people I already know. There's a few of our NDRS colleagues here. Hi, everybody. This course is a follow-on from the Introduction to R course, which some of you may have done, some of you might not have done, and come straight into this one. That's absolutely fine as well. What we go through today are some ever so slightly more advanced R techniques to take you to that next level. And we take it at a pace that suits the cohort that we have in the room at the time. Okay, so we don't want anybody in this room getting left behind at any point. Please do shout at any point if you have questions. I guarantee there'll be somebody else in the room that could do with a clarification as well. So we learn together, we make mistakes together. I make mistakes with you as well. So what we need to be doing is taking everybody on the journey with us and hopefully get to the end point together. Hopefully you all got an email that gave you instructions and links as to where to go to get today's materials, but we will spend a little bit of time first of all getting those, just to make sure that we're all starting from the same page. So I didn't even introduce myself. So my name is Dr Claire Welsh, for those that don't know me. I'm lead data scientist at the strategy unit, which is a specialist NHS unit. And we do lots of different pieces around analysis and evaluation and building data science tools. And I've been working with R for probably the best part of a decade now. And similar to quite a lot of you in the room, I started off learning a little bit of R to do a particular job. So I learned what I needed for that particular job. Then started to branch out a little bit and get interested in R's capabilities. And that's a really common way that people come to R. It's got a low barrier for starting up and doing something, right? But it's sometimes hard to take those next steps, which is why, as the NHS-R community, we've set up this training for everybody to come along and learn some bits that you didn't necessarily know, consolidate what you already know, etc. So myself and Kaylee are, we run the NHS-R community, which is hosted by the strategy unit, and it's all volunteer-led. So this course is free, as you know, and all of our courses are free. All of the materials are provided free of charge, fully available for you to take and do with what you wish on our website. I'll ask Kaylee to pop some links in the chat in a minute so you can go and see those. And we have a lot of different courses on there, not just these introduction and intermediate R courses, but we've also got things like working with Quarto, working with Git. We don't necessarily always run those courses in a meeting format like this, but all the materials are there, all the training stuff is there for you to go and take it and do with what you will. So we would love you to get involved today. You get as much out of this as you put in, as with everything else. So it's one of those that definitely ask questions. If you're not understanding something, do get involved. If you want to ask a question but you don't want to put your camera on or don't want to speak up, feel free to pop it in the chat. I'll do my best to keep an eye on the chat, but Kaylee's here to help me do that as well, because I tend to not be able to see it when I'm sharing screen. So we'll do that. Okay. So in the email that you received, you should have had some links to the training materials, but I'll go through how we get those if you don't have them. What we usually do is we use Posit Cloud for doing this training. The reason for that, what that is it's an online version of RStudio and R. And the reason we do that is so that everybody in the group has the same version of R, the same version of the packages, get around all of those firewalls that your employer might put in the way of you being able to download and install packages yourselves. If, however, you have R and RStudio already on your computer, that's absolutely fine. You can use it and do the same things. It'll look very similar. Where there's differences, you can pop your hand up and ask, or I can hopefully remember and tell you the differences that there are there. But Posit Cloud is usually the best place to do this. If you were on the Introduction to R course, which was a couple of weeks ago, if you've done a lot since then in your Posit Cloud account, you might have got to the level where you've hit the usage threshold for Posit Cloud. There's a small free tier essentially in Posit Cloud. So if you have done that, hopefully you already have RStudio and R installed on your machine and you can work from locally. But let's go and have a look at the materials that we asked you to install. Right, so thanks, Kaylee. Kaylee's popped in the chat some of the materials that you need for this course. I'll share my screen so that you can see what I'm doing. Okay. Yes. Okay, so I should be sharing my screen now. So this is the NHS-R website. So we can go into events and training. On the training tab, I'll get rid of these. On the training tab, we've got lots of bits and pieces of information about the NLP and R course, but our resources are here as well. If we go into books, the NHS-R Way book is the one that has all the information, I think. Double check. So we click through to go into the NHS-R Way book, and there's a training chapter here. So these are the free courses that we've got at the moment. And if you click on the intermediate R one, it'll ping you down to this section here, which tells you how to get hold of the materials. So as I was saying, you can either do this on Posit Cloud, which is what I will do now. So I'll log into my Posit Cloud account, posit.cloud. It should already be logged in because I was here earlier this morning. You may have nothing in the content when you log in, which is absolutely fine, because what you're going to do is create a new project from a Git repository. So if you've not done this yet, what you need to do is go to the top right here, the new project button. The bottom option here says new project from Git repository. So you can click onto that, and in the URL, you'll put the URL of this one essentially, which is the intermediate R training repository. So you can copy this, pop it into here and press OK, and it will open that project for you. I've already done that, so it's here. So I'll just go back into it. And if you wanted to do it on your own computer, the instructions are there. We can go through that if anybody needs to. Has anybody not managed to get hold of the script that we're going to work on today? In this way, you'll get into the project. Please do shout up if you haven't. I don't want to start off if anybody's not even at that position yet. If there's silence, that's
hi,
good.
morning.
Hi.
Would you kindly show us quickly how to do it on RStudio, please? Thank you.
Absolutely, not a problem. So if you've got RStudio installed, let me just bring up mine. I'll be sharing the wrong place at the moment. Give it 1 sec to start up. I'm just going to not share this RStudio screen until I've made sure that I'm not showing you a project that you're not allowed to see. So I will close that project first. Okay, so here I've got a blank. Let's close it all. Make sure. So we've got a blank RStudio session set up here. And what we can do is we can use this. There's a package called use this, and there's a function called use course. And what this will do is we will copy all of this. We need the use this package and we need the here package to make this easy. So we'll paste these into the console, get rid of the commented part, just press enter. So what RStudio is going to do is going to go and get the use this package from CRAN, the here package, and then it's going to run that course, that collection. And shall we delete the zip file? Yeah. It'll change these options. So the affirmative one will change position just to make sure that you're paying attention to what you're doing. And then it will open another RStudio pane, which is here, which should have all our course materials in it, as you would see on the Posit Cloud. So I'll give it 1 sec. And you'll know you're here if you have this intermediate R training project identifier in the top right of your RStudio pane, and you'll have all these files. Give us a thumbs up if everybody's got this to this stage, either on Posit Cloud or on RStudio locally. Good. And anyone struggling? Anyone not got it?
Yeah. Sorry. Yes, I followed everything. Can I share my screen with you, please? Like
yes,
we
did
a few weeks ago. Perfect. Thank you. Good things did happen when I pasted that URL.
We're local, are we? Yeah, we're local at RStudio.
I'm not in the right project though.
No. So if you click on the project identifier in the top right, close that project. Yeah, so it's that, yeah. And then we'll just start again. Okay, so now we can, you may not have used this installed. Yeah, no, that's fine. So I'd say number 2 for definitely. I do want to install those things. And it should open in a new window, probably. New session.
Nothing's happening.
That's interesting. Let me see. So it's got a, I'm sorry, it's blue, so it's really hard to see. It's got a, you see where it said opening and it's giving you a big file path?
Here.
Yes. So you try clicking that. And if you, or go to the place that that's talking about on your computer, on your file explorer, and you should have the project there.
Right. I'll have a quick look. Thank you. Documents.
I can see it there in your files pane, actually. So it's the bottom one in your files pane, I think. Yep. So if you click on that, and then if you double click on the R project file, the R proj file, which is the one with the little see-through blue box, it's about halfway down. Double click there and just say yes, and that should open the project for you. There we go.
Wonderful. Thank you so much.
No worries. Anybody else struggling, or is everybody with us now? Silence will be a good thing. I'll assume it's a yes. Okay. I'll work Composite Cloud today just to show you how that works. So we don't have slides for today, okay? We've got a setup where we're going to work through a script together, piece by piece, and we'll go at the pace of the class, so we can go more quickly or more slowly, whatever you like, as long as everybody's coming along with us. We'll take breaks. Generally speaking, we take a break around 10:30 and then another one around 12. But if you're desperate for a break, just put your hand up and tell us, or put it in the chat or whatnot, and we can take breaks at different times. So what we're going to do, let me make this a bit bigger for you to see. In our R, we've got two .r files. We've got the intertrain student version and the intertrain. So what we want to do is open the intertrain student version. Okay, this is the script that we're going to work through piece by piece today. So if everybody can open that up, don't click on install in the top banner here, because we'll talk about installing the packages a little bit later. Lauren.
Claire, are you meant to be sharing your screen?
Sorry? Oh, I'm not sharing my screen. Of course I'm not. Sorry. Thanks. Well done. That will not be the only time I forget to do that today. So do remind me. Okay, so hopefully you found the intertrain student version.r anyway. If not, here it is in the files if you're in the right project. So you can click on that to open it in the editor. You'll have probably this yellow banner at the top that's talking about the packages that we don't have yet. Ignore that for now. You can close it if it's annoying you. And this is what, oh, don't worry about if you've installed them already. It doesn't really matter, but you won't be able to install them at the time we install them. It's fine. Okay, it's just so that we all get to the same place eventually. So the intertrain is the same script, but with the answers in. Now, it's going to be tempting to go and have a look at that. I would really, really suggest you don't. We need your brain to be doing the slightly uncomfortable thing of figuring the answers out, because that's how we'll learn, rather than just be told the answers and memorize them. If at any time you need help on a function or anything, then there's a reminder here to say that if your cursor is flashing on a function name, you can just press F1 on your keyboard and it will open up the help file for you. So that's a nice easy way of getting help. Or you can type into the console down here a question mark and a function name and press enter, and that will do the same thing. Google is always your friend as well. So Google is always open whenever we are coding. This was written, by the way, by Simon Wellesley Miller, who's a really, really good friend of the NHS-R community. He works in NHS England. So any spelling mistakes are his, I'll put it that way. But thanks to him for creating this. Okay, so let's make a start. So what we're going to do is lots of data wrangling. So as a lot of you will know, already being analysts and whatnot, data wrangling takes up a lot of our time at the start of any project, and it's really worth taking that time to make sure we're working with as complete, clean and well-structured data as possible. That makes everything else a lot more easy. We might do a few graphs and plotting. That's not really what the focus is. There is other training available, as you saw on the website, to do those other things, but we'll touch on them a little bit today if we get through everything. So we do assume a basic level of knowledge of R. Is my screen big enough for everyone, by the way? I didn't check. I'll go in another thing. and a bit of dplyr as well. So dplyr is a package that comes within the tidyverse as well. You can install it by itself, or you can install it by installing tidyverse. And dplyr is great for doing all the data wrangling type steps. So we'll assume that you know a bit about dplyr, doing basic filters and selects and whatnot. If not, and all of this is sounding completely foreign to you already, I mean, feel free to stay and carry on. But if you are completely lost, it might be worth you coming out of today's session and signing up for the next introduction to R session. I'll leave that up to you, though. You're absolutely welcome to stay and carry on with us if you'd like to. But if it's feeling really, really unfamiliar, I think you missed a step, so you might be best going back one. I'm also not going to go into great depth about RStudio itself and how it works and how we use it, although we'll be touching on a lot of that as we go through. So yeah, so we'll hopefully all be in the same place with this. So we'll be using the modern pipe syntax here. So this one here, which is the straight line, so a pipeline, which on most keyboards is control and then there's a backslash and the pipeline, and then that greater than sign. They're almost exactly the same in the way it works from this pipe, the old-fashioned pipe that you'll have seen and will still see in a lot of different places. This pipe symbol is basically from the Magritter package. So the native pipe doesn't require an extra dependency, doesn't require us to load that extra package in. So it's generally speaking better to do this pipe now, the modern way, rather than piping in the old way. But if you're still doing this, it should still work. There's only a few strange edge cases where these work differently. So you should be fine with the modern pipe. So first and foremost, let's load in the libraries we're going to be using today. So we'll talk about the code around this later. So we can run these bits of code. So my packages are tidyverse, NHS-R datasets, and pacman. So as you remember, you can either highlight and run, or you can, when clicking on, when the cursor is on a line, you can hold down Control and press Enter to run a line. And all this is going to do, this first part, well, we'll talk about it in a moment, so I'll not talk about it now. And then we're going to run the not installed. So it's going to check for which ones are already installed and which aren't. And then run a little if statement. And it's going to install them if they're not already installed. And you can see it's going away to CRAN to go and get all the dependencies, all those packages, the packages we want depend upon. So it'll take a moment to do that. So feel free, be clicking along while I'm doing this. If you have any issues, do shout. It'll take a little moment. Don't know if any of you had it, but last night our internet went down because there was a global Vodafone outage. I was like, great timing to have in the day before I'm teaching. Lauren.
I don't know if I'm being really silly, but I'm doing what I would normally do on the cloud on my normal. When I click run, it's only doing the very top line, so it's not doing.
You'll need to highlight all the lines you want to run. Then
yeah, I have.
And it's still not doing it.
And when I click run, it's only putting the top line into the console.
That's bizarre. The other way you can, it sounds like you'll have a setting in the background that's specified that key binding only does one thing. I don't know why it would be like that, but the other thing you can do is highlight it, Control C, and then Control V down here, and then press Enter. It's the other way to run things. Generally speaking, holding down Control and pressing Enter should run everything that's linked together. Excuse me.
Yes, that's how I'm used to it working. Okay, I will try and work out what's going on.
Yeah, I can work with you on that later on, maybe in the break, to figure it out. But it sounds like something local. So, okay, and then we'll run pacman pload. So we're going to load up those packages. Remember, installing packages is basically buying the book from the shop and putting them in your library, and then loading the packages. We need to get the book out of the library to read it, to actually use it. So loading it is bringing into memory those packages that we want to actually use. Everybody managed that? Hopefully. Okay, so let's look at some useful base R functions. So let's run data. So we're going to create an object called data, and data will be the AE attendances file, which is some data that we already had in our plot.doc package that we loaded up earlier on. So now when we look across in our environment pane, we've got an object called data that again we can click on to show the data in the viewer. And we can see that we've got a nice time series, which we'll use later on. So we've got dates here, we've got organizational codes, types, and then some counts of things: attendances, breaches, and admissions. Hopefully everybody can see that. So it's a big long data frame of nearly 13,000 rows and 6 different observations. We can use the call names function to understand what the columns are called. So this data is in tidy data format. So every row is an observation, and every column is a variable, a field. Okay. So this is the way that all data should be, ideally, in the world. Simple flat tables, as we know, that are in this 1 row per observation format. So to get the column names, we can run call names. Call names is useful. There is also a function just called names. Names works on data frames and various other things as well. So names of data gives us the same output as you can see that call names does. So we can see the names of those columns that are in the data object. Then it's a little bit of base R. So some of you in the room may be as old as me and learned how to do base R before the tidyverse came along. The dollar syntax is a way to access a component of an object. So data is it because RStudio knows that it's a data frame, it has components that are the column names. So data dollar type, if we just run that, gives us the whole column that is the data type column. So it's a vector of information using the dollar. So that's a syntax where you want to obtain a component of the object. If I just write data dollar and don't type anything else, you can see that RStudio gives us a nice little list of things that we could have chosen here. So if you don't remember how exactly you spelled your column name, this is useful you can just click on one of these and it will give you the correct spelling of the column names. There's a really useful function called unique that you probably have already come across. So let's get how many unique data items are there. So how many unique organization codes are there in the data frame? So again, we can use the dollar syntax to say organization code. That was our column name. Unique organization code is all of these. So these are all of the organization codes that exist in the org code column. So it's all of them listed out in, I think, alphabetical order. Maybe not alphabetical order. Never mind. So this is all of them. So it says here we've got 274 levels. So there's 274 unique organization codes, and this unique works on strings. It works on other types as well. So if he said here, notice the bit of base R. It's useful for certain things, and it is a good idea to understand some of the basics at how some of the things work. The dollar sign allows us to call a column from a data frame as a vector. With other object types in R, the dollar sign gives you other elements, not necessarily the column. So if it's not a data frame, your object, then the dollar sign will do something slightly different. And it depends on what the object is as to what it will do. But if you're not sure what objects there are, like I say, you can just have the object name and dollar, and then a list will appear of the things that you can select from within that. Okay. It's also possible to select a specific entry within that vector with square brackets. So this, if anybody here has done anything with Python or Julia, I think, you'll know that when we're indexing in those languages, when we're identifying things by their position number, if you like, Python and Julia works somewhat differently in that they start counting from 0. So what in common parlance you would call the first element is actually the 0th element. R does it the way that you would expect as an English speaker, should we say. So R, the 4th element is called 4 in square brackets. So what we're asking for here is of this object, get me this column and the 4th element of it. So let's just control enter on that and see what it gives us. So it's given us a 1. That's the number that should be the 4th element in the type column. So 1, 2, 3, 4. And you can see that's correct. You can put any number in here within the square brackets as long as there exists a row with that number. So given it's the 4th or the 100th, so we've got what, 13, nearly 13,000. So if I put the 12,000, what's the 12,000th element? Is a 1 as well. Apparently that's boring. So in this way, you can index quickly into a vector. Does everybody know what I mean by a vector? It's really difficult with the intermediate art. If people haven't come from the introductory arts, it's difficult to know what level people are at. So if I'm using terminology that's tripping you up, please do let me know. I'll continue with the terminology that feels natural, unless somebody says, can you please stop and explain? Okay. Another way we can index things as well is doing a range. So with the colon in between, what we're asking for here is the 4th to the 10th. And this is an inclusive range, so it'll contain the 4th, 5th, 6th, 7th, 8th, 9th, and the 10th elements if we run this. So yeah, so 4, 5, 6, 7, 8, 9, 10. All these elements in a row are the 4th to the 10th elements going down here. Okay, so that's the colon that can give you a range between the starting figure and the ending figure. Again, this is slightly different in Python, where it's not inclusive of the upper number, the upper range. So if this was in Python, we'd be indexing 4, 5, 6, 7, 8, and 9, but not the 10. So again, that's something to keep in mind. You're fine if you're not going to be coding in Python. But these little things do trip people up. Oh, here it is, it actually says it. So yeah, never mind, we've already said that. That's good. Okay, so we had our unique organization codes above, which is where we were asking the computer to tell us what are all the unique organization codes, gives a list of the entirety of them. How many different ones there are, we did get from doing that, but we don't necessarily want to see all of the organization codes. This n underscore distinct is a really useful little function that will do, as it says on the tin, really, what is the number of distinct organization codes? 274. Tell you what, while we're here and my cursor is clicking in the n distinct, I'll press F1 and show you the help file for this, just to prove that you can get them this way. So you should all be familiar with the structure of a help file. You've got the function and then the package from whence it came in the top left. You've got a bit of a description. You've got the things you need to give to it, the arguments, and then it tells you what it will get out. With new functions that you haven't used before, I find the best thing to do is to come right the way down to the bottom of the help file, which has the examples in it, and you can get a really good understanding of how it works and how you use it down on the bottom here. Okay. And then if you wanted the range of a numeric variable, funnily enough, there's a range function. So let's do this and see what we've got. So the period function, if you remember, is this date format column. And this is the universal date format where we have year, then month, then day. And that disambiguates it from the US and the UK versions. So with a range, it will understand that it's a date. So it'll go from the earliest to the most recent date. So this is the range of the data period. If you weren't sure whether it was taking in this first column as a date, you can look at the data object in your environment. Click this little down button. And here, data period, the first column, it already knows it's a date and it knows what format it's in. So you can be convinced that it's handling dates as dates. That can make things a little easier. Another useful one is the structure function. And you can run structure on anything in R. So this format of data, the structure of it, is actually a tibble, which is, just think of it like a table or a data frame. Tibble is a little bit more efficient in the way that it does some things. So they're lazy and they're surly, which are actually good things in coding. So this table, we've got these different columns, and just as we showed up here, it's got the information about what types of thing are in each column. And we've got 3 numbers, 2 factors, and a date. So structure of anything can be run, structure of a scalar number, structure of a vector, structure of a whatever it is. So structure is a really useful function to have in the back of your head. How do we quickly see the first 5 rows of the data? We have a head function. So head will automate to 5 rows. So this gives us the first 5 rows in order of the data set called data. And you can convince yourself that that's correct by looking back here again. You can see the numbers match up. You can also do the tail of the data, which, as you can imagine, is the last 5 rows. If you want a different number than 5 rows, you can specify that within the head function. So if I type head here and open the bracket, it tells us head of what, and then the ... means there are extra arguments you can pass to this function. If you don't know what that means, maybe click your cursor into it, press F1 to bring up the help file and see what are the ... What else could you give it? So arguments passed from other methods. So you can read through that. You don't need to read through all this right now, but we can see that the second argument that we can pass with it if we want to, we don't have to have this argument, is the number of rows. So going back to our here in our editor, if we run head of data 15, we're going to get the first 15 rows. Just get that first. Go. Nice little shadow row numbers here to make you convinced that it's giving you 15 rows. And similarly, you can do any number. What's quite nice is you can also run the, so top n does the same thing essentially, but with dplyr. So top n of data and 15. So head and top n do the same thing as tail, and I think it's bottom n, I think it is. So that's just preference as to which one you would like to use. Okay, so we can also find the top fraction of data, which can be really useful. It's one of those little functions that you don't know you need until the very use case pops up and you go, oh yeah, I couldn't think of an example off the top of my head as to why we would need this, but we can see the first proportion of rows as well using dplyr, using the top fraction. So top frac of data, and we give it the 0.15, which is 15%. So if we gave top frac 1, it would give us the entirety of the data set. Top frac 15 gives us something like 2,000 rows, which is about right. We can also give an option of an argument with an ordering here, top fraction. So here we're asking for the top 15% of this data object based on the attendances, which, as you remember, is this numeric column here. So what's the top 15% of the rows of data of the top 15% of attendances? So let's have a look at that. So what this has done is it's reordered our data set to have attendances be in this structure here, the top 15% of them. And again, it'll be the same number of rows as previously doing the 15%, because remember, 15% is of that same data set, but here we're doing it based on attendances. So that little run through is just a little grab bag of useful functions. What I'd like you to do, provided you've all got the AE data as we loaded it in earlier on, I want you to see if you can find the lowest 5 attendances within the data set. So I'll give you a moment to do that. Give me a thumbs up when you've managed, and we'll go over the answer. I'll stop sharing my screen just for a moment. Anyone managed? Well done, Lauren. Oh, and Edwin. You have it 30 seconds. Well done, Jenna. Okay. Where have you gone? I'll share my screen again and we'll come back together and have a look at one of the answers for this. So one of the solutions, there's lots of different ways of doing everything in R, okay? So you might have a solution that does the job, but looks slightly different to what I'm going to put in here. So we have the top n function, and it seems strange to use the lowest 5 on top n, but what we can do is we can use the minus in front of the number of rows that we want. And this is you'll find this is a way of doing the inverse of lots of different things in R. So the top n of the data frame, but the lowest 5 based on attendances should give us the lowest 5 attendances, which are these small numbers here, 1 to 6. Did everybody get something along those lines? Anybody confused? No? Cool. Okie doke. Let's move on then. So we can see summary statistics of a data frame, and summary is used all the time. So you will find summary used throughout your work. It's really, really useful to run as check. It's useful in lots of other ways as well, especially if you're doing modeling. So extracting a summary of like linear regressions or whatnot can be a really nice way of working too. Oh, yes. I haven't read the comments in this. So yeah, he's right. Linear models, useful for that too. So if we run a summary on our data, on the data frame that we have, it's going to give us what you would expect. So it's going to give us each of the columns that are in that data set, and it's going to give us a little, if it's a numeric or a date column, it's going to give us a little 5-number summary, 6-number summary, the minimum, the quartiles, the median, mean, and the maximum. If it's a factor column, it's going to give us a count of the different factor levels. And then we have type as well. So we've got 1, 2, and other. And then these 3 columns, attendances, breaches, and admissions are all numeric. So again, we're going to get that sort of 5-number summary looking thing with also a median in there. And so summary is very useful to get an idea of the ranges of your data as well as anything else. Table is a function that is used for counts and proportions as well. So a quick table by a column. So here, let's have the counts of type, which we know are either 1, 2, and other. Let's do a table of that and see what we get. So because the data type column is a factor, essentially, we've got 3 different options. We've got 1, 2, and other in that column. And you can convince yourself like this, 1, 2, and other. And the counts of these are below in this little mini table here. So table, very, very simple. Again, R, you don't have to have this space here. I tend not to put spaces after them. Simon tends to, doesn't matter, it's up to you. R will behave nicely either way. You can also do tables by 2 different columns as well. So again, counts by 2 different columns. So this is the cross table, if you like. So let's right away to the top here. So along the top, we've got every single one of the organization codes. And down the y-axis of the table, down the column, we have the options for type. So we've got the intersection of every permutation of organization code and type. Because we've got lots of organization codes here, it looks a bit ugly. So you wouldn't necessarily do this in this way, but it's a useful way of getting an understanding of the distribution of your data. So we can see that ROA exists across types 1, 2, and other. R1A exists only in type 2, etc. So you can get a little bit of an understanding of the distribution of your data with table. You can imagine you can add 3 columns, but it does start to get a bit silly looking and not very helpful to do that. So you can feel free to play about with table and see if it gives you what you want. I find tables really useful in the really early days of an analysis where you're sense checking what the data looks like. A lot of the time, as you know, is spent bringing some data in and then checking whether everything is associated with everything else in roughly the way you would expect, and if not, why not? Especially having a look for missing data is useful as well. Okay, renaming columns. Okay, so we remember the names function. So the names of our data set are these. Column names is also another function you can use to get the column names if you want to be more verbose about it. Spaces in variables names are not a good idea. So you can see this org code, it's called org_code. R and lots of other coding languages really don't like there to be spaces in the names of things, be that names of objects, names of the variables within data frames, names anywhere essentially. So we tend to try to remove them. But you'll find a lot of data that you'll accept from other people, especially if it's been built in Excel or something else, will have names that have spaces in them, which can be a pain. What you don't want to be doing is to manually be altering the Excel file before you then import it, because that's going to be potentially introducing some errors. So what we can do is we can rename with functions in R instead. So let's rename our org code, which had an underscore in it, to organization code, so that we can see what we could do with this. So that you wouldn't really be doing this. You wouldn't be introducing spaces, generally speaking, in R. But for argument's sake, let's do it here. So what this bit of syntax is saying is take the data, well, we're going to create something called data. We already have something called data, as you know. So what this is doing is overwriting our existing object called data. What this new thing called data is going to be is take the data that we have, then rename, and with the rename function, the new name comes first. The new name equals the old name. So I run this. If I just ran this bit without reassigning it, it would show me, let me do that. It would show me in the console what happens. So it would create data with the right name on it, but only in the console. It hasn't changed anything about the actual data set in the environment, because if we haven't assigned it back to that data set. So to run this whole thing is how we can then see that we've changed the name in the object as well. Okay, so that's part of the reassignment here. Let's rename some more variables to something that we don't like. So again, you'll get data from people that's got all sorts of nonsense in it. So here we've got a random capital, we've got something in all capitals, we've got something with a leading white space, which is horrible. So let's do all that in one fell swoop. You can see we've got some yucky names here now. Okay, there's a package called Janitor that probably you've already come across. Janitor's dead useful, and part of almost every script that I write starts with installing tidyverse and installing Janitor. So let's load it up now. Actually, yeah. So I haven't installed Janitor yet, so let's install it. Install.packages Janitor. It'll go away to CRAN and go and get, it's only a little package, but it's a very useful one. So it's in my library now. So let's go to the library, get it out and open it up. It'll give us a little message saying, by the way, some things are masked from stats. Does everybody understand this message? Anybody want me to explain it? It's kind of tangential to what we're talking about today, so it's not essential to understand it, but if anybody wants me to, let me know. Okay, Emma wants to explain it.
Sorry, it took me a while to unmute. Could you explain it, please?
Yeah, of course. So when we load a package, a lot of packages use the same names for functions. So especially when they're names that are in plain English, like summary. Lots of different packages have got a function called summary, but they might do different things, those summary functions. So when you load a package, what R will tell you is, oh, by the way, the function name summary is masked now from the previous way it worked. So what this is saying is when we've attached Janitor, we have masked the stats packages chi-square test and Fisher test functions. So Janitor has got its own versions of these. And so it's just a note to let you know that, by the way, now when you use the chi-square.test or the Fisher.test functions, you'll be doing the Janitor version of those, not the previous stats version of those. Okay. Often this doesn't matter, but it does matter sometimes. So there are packages like, what's the one I always trip up on? There's a filter function. Obviously, a filter in dplyr is dead useful, and we all use it all the time. There's also a filter function in one of the graphing packages. I can't remember which one. So when you're doing maps and whatnot, if you've loaded that mapping package, whatever it happens to be, it will mask filter. So when I run filter, I'm expecting the dplyr version. But if I've loaded that mapping package after dplyr, it will be using that other one, and it will throw me errors because it's not giving me the output I'm expecting. So there's ways of specifying which one you would prefer. We won't go into that today necessarily, but the order you load the packages in matters. So if you load package B before package A, and they've both got a function that has the same name, package B's one will work natively once you've got that loaded. So this is just a note to make you aware of that it's masking these two functions. Okay. So the janitor package has got a really nice function called clean names with an underscore in it. So again, we're going to reassign this to data so that we overwrite what these ugly names are now into clean names. Let's see what that does. Aha. So you see the difference here. We've got all lowercase, which is nice. We've got no leading white space, and we've got no spaces. All the spaces have been converted to underscores. So in this one function, that has cleaned all of our names really nicely for us into more R-friendly names. And so we don't have to go through manually changing anything, which is really useful. Okay, another little thing for you to do then. On your own, in your RStudio or in your POSIT Cloud, have a quick try at renaming breaches to the number of breaches. As we did before, you can scroll back up and see how we renamed things with the rename function from dplyr. Then put it back again. So I'll give you 2 minutes to do that until 9:50 on my clock. I'll stop sharing as well because it's distracting. Okay, hopefully everybody's there or thereabouts. I'll share my screen again now. Okay, how can we do this then? So let's make sure we actually reassign this to the data object. So let's take data, and then let's rename, as we did above. We use backticks in R to have longer names. Let's do, what did we say to call it? Number of breaches. Number of breaches. So if a name does contain spaces, you need to wrap it in backticks, otherwise it won't know it's all one string to be kept together. So that's the new name. The old name was just breaches, wasn't it? Yeah, breaches. Breaches. And note that we don't put the old name in quotes or anything like that, because we're not referring to a string here. We're referring to a column name. So we know it's a column name. R knows it's a column name. So let's see if that works. Rename, see, yep, so that's worked. That's created this horrible thing with capitals and spaces in it, which we don't like. So let's have, so we can see that already. We don't need to run anything else there. So let's put it back again then. So how did people put it back again? Anyone want to hazard a guess? So there's two ways, given what we've shown you this morning, that you could do this. You could do, again, data is data, then rename. And this time we'll actually call it breaches. Oops, number one. Breaches. And then that will be this one here. That would work. Equally, we could run clean names again. So we could say data is data, then clean. And if you, so the autocomplete in RStudio and in POSIT's really, really good. So I've just written clean name and it said, do you mean clean names? Yes, I do. And we can run that. And there, so it's given us number of breaches with an underscore instead and taken the capitals out for us, as we said before. So hopefully everybody managed to do that. Give us a thumbs up if you managed to follow that along, and that all seems fine. Good. Cool. Okay, so clean name is a really useful one. So do remember that one. Janitor's got some other helpful functions. So dates are always a problem, right? And if you're working with any kind of Excel anything, even if it's a CSV file of data that you've had to load into Excel for whatever reason, it will do stupid things with dates. So dates can be really, really difficult, but Janitor's got lots of different options for how you can do that. There is a shortcut key, Renee, to the pipe. I don't know what it is because it's only 3 keystrokes to just do it normally. So I just do it holding down Control, press the pipe, holding down Shift, I should say, press pipe, and then keep, Control Shift M. So it's the shortcut's the same length as the just typing it. So it's up to you whether you use the shortcut or not. Okay, so other things that Janitor can do, it can convert Excel dates to dates, find duplicate rows, add quick totals. Libraries is spelled wrong. So yeah, and he does the same thing as me. Tidyverse and Janitor are the 2 of the absolute core ones. You don't have to use them, but they do make life a lot easier. So let's rerun this to make sure that the data thing is back to how it was when we first started this morning. So data is the AE attendances dataset. So then let's look at select. So select is a statement in dplyr that always refers to columns. Okay, so we've got 6 columns in this data frame, and we will refer to them using the select method. So let's create something called data select. So data select is, you take the data object, then you select columns, period, and organization code. These don't have to be on separate lines, by the way, and there doesn't have to be a gap here. It works perfectly well having them on the same line. So when we run this, what we're going to do is we're going to create a new object called data select that it only has the period or an org code columns from the data object. And you'll see this come up in your environment as another thing here. Let's close this one. So we've got another data frame here, or tibble. It's got the same number of rows because we didn't say anything about taking fewer rows, but it's only got the 2 variables, the 2 columns. So let's just click on it and just convince ourselves that we've got the period and we've got the organization code. This little line 216 here, you can do view, but actually it's a capital V. Will do the same thing as I just did. When you click into the environment, into the object, it will open the viewer. And also if you run view with a capital V of the thing, it will do the same thing. Okay, so, and I almost never write it into a script because viewing as part of a script is a strange thing to do. Viewing is kind of an interactive thing to do as you're working. You don't necessarily want to create that again and again, but it's up to you. Okay, but not the same as above. So yeah, if we reverse the order of the columns that we've selected, it will create that data set in that order. So if the first one we did had period, then organization code, let's do organization code, then period. And it will create them, the new tibble, that data frame, in the order that you've specified the columns. And again, we'll not bother doing that because I've just looked at it. So I've included a view statement here to look at our data. There are various other ways to achieve the same without having to do so much or indeed any typing. Yeah, okay, so we've already talked about this. There's various ways you can look at data. I just click on the name of it in the environment pane, generally speaking. You can click on this little, what is it? Little graph paper thing as well. And that, yeah, you can hold Control and click on an object name as well. So if I am going to show select, you can do that. So I held down Control there and clicked it with my left-hand mouse button, and it opens the object here. Yeah, so that's his one. Back to coding. He's got a very specific style, has Simon, so you can tell. Okay. With the select statement, where we're talking about specific columns, we can do renaming on the fly. So we don't have to separately rename columns, which is quite nice. I always forget about this. This was something that I think Tidyverse added in a little bit after the Tidyverse became a thing, essentially. So it wasn't something that I picked up naturally, but if you can remember this is something you can do, it does save you a few lines at least. So let's create data select again. And what it will be is data, then selecting something called date period. This is going to be the new name for period, and organization for org code. Let's run this one and we will open it up. So now we've got these new names that we've created for the columns, and we've created them within the same select statement. So that's nice and quick and easy. No speech marks are needed as well as you do it like this. You just need to remember, ideally, that the first one is the new name and the second one is the old name that it had for the column. So you can see how that's relatively powerful, kind of useful. In R, if we want to negate something, we often use an exclamation mark just before it, and that means the negative of that, the opposite of that. So if we add it in here, we've got data select, which we're going to create as data, then select. And what this is saying is not a combination of org code and period. Does anyone want to guess what this will produce if I run this? Be brave.
Is it a data frame without those two columns?
Exactly. Yeah, exactly. So it's going to be the inverse. It's going to be all the columns except those two. So this C is a concatenation. I think it sounds like concatenation or combine or something like that. Maybe combine. So wrapping things in a C with these is just combining them together. So it's saying I don't want these two columns. Without the C, this wouldn't work, because what you would be saying there, if I delete this, the C, what you're saying is I don't want organization code, but I do want period. If you don't want multiple things, then you'll need to go back to combining them. This is the combination of all the things I don't want, which is organization and period. Okay. Yes, so if there's multiples, you have to put them into a vector, as I've just done here with the combination or combine. Yeah. Okay, so you'll see that this doesn't really do what we want, but we do combine them. We can also, as we did earlier, use a negative. So a negative in the sense of these columns means not that as well as the exclamation. So let's run this and see that we don't get organization and period in data select, which we don't. So that's nice. That's just lots of different ways of doing the inverse of a selection statement. So if you just keep in mind that select means columns in dplyr land, that'll really help. You can imagine lots of other packages have a select function as well, but they're not all to do with columns, not all the same thing. So select in dplyr is this version that we're talking about today. Some other nice verbs, functions that we can use are, they do what they say on the tin, which is what I really like about Tidyverse, right? It's like the functions are named really sensible things. So if you're going to do a select statement for every column that contains ES, then you write select contains ES. What do we get from that? Reach ES and attendance says, because they have ES in the name. If you want all the columns that don't contain, then as you can imagine, we can preface it with the exclamation mark, which means negate this phrase. So data select will then be all the columns that don't contain ES, which should be all of the other columns. So that's quite nice as well. You can also do select, and when you've got huge data frames and you want to do something to all of the columns that share a data type, so often where it's numeric, you can, and I literally just said it accidentally because it follows the English way you would say it. I want to select all the columns where the data type is numeric. So in our data set, the numeric columns were the attendances, breaches, and admissions. So it's done that for us. Obviously, if you're going to be doing it like this, you need to convince yourself at the start of your analysis, at the start of your data wrangling, that things that should be numeric are numeric. And you can do that, as we talked about, with looking at the structure of the data, either by running str or by looking at the little bits of information you get here. So you could do, and the is dot has got lots of different types of thing you can do. So let's do F1 on this and see if it gives us a nice help file to say what other things we could do. So it's in base R as well, so it's not in a package, which is useful. There's other versions. Where's the C also? So there's also is double, is integer, is storage.mode. There's other is functions as well. Is na is a very useful one. Na means not there, basically. Okay. And a really useful one, again, sometimes you'll have loads and loads and loads of columns in your data frame, and you don't want to have to write them out to make sure that all the columns are in the right order. So what you can do is use the everything with ellipsis, and that will do as it says on the tin. What you've said here is create data select, which is data, then select the admissions column, breaches column, and then everything else after it. And the everything will be all those other columns in the order that they originally were. So let's run this just to show you. So we've got admissions and breaches, then all the other columns. Okay, so that's just a really nice shortcut, I should say, to order the data frame in the way that you would like it to be. Right, another little thing for you to play with. So can you please select the data so that it's in order of admissions, any column that is a factor, and then everything else, or anything else that remains. Have a go on your side doing that, and I'll stop sharing. Give you a couple of minutes. Here's a thumbs up if you've managed to get to that point. Right, that's 10:05. Let me share screen again. We'll come back together. So what we want is a data frame that is going to have the admissions column first, then anything that's a factor, then everything else. So how we could do this is, let's again call it data select. Will I share my screen now? And it's going to be the data table. Then let's select admissions, then anything where is a factor, that's it, where it is a factor, then everything else. Okay. Again, you don't have to be doing these on new lines. You could have one whole long line here, right? But generally speaking, to make code more readable, you should make it long rather than wide. And you'll see this grey line, which you'll all know is a sort of opinionated maximum length for the lines. So we tend to put things on a new line after an operator or after a comma. So let's run this. Does it work? Yes. Okay, so our admissions column is first. We have these factor columns, organization code and type, and period actually. And then, oh, well, no, organization code and type, period was a date, wasn't it? And then these two other ones. So did everybody manage that? Does that make sense to everyone? Do let me know if I'm going too fast or if anyone's confused. Happy? Oh, good stuff. And again, there's probably 1,000 different ways you could write that bit of code. If you had something slightly different that does the job, fine. That's the magic of R. I'm just showing you one way of doing these things. Right then, let's move on. Okay, alternative joins. Joining data sets together, very common, often a pain in the neck. So standard joins are covered in the introduction course in some detail. So if you've done the introductory course, you'll know that we've got left joins, inner joins, right joins, full joins. And all of that is based on which rows do you want to keep. And do you want to keep everything from the left-hand table, from whatever the first thing is you're joining to, or everything from the other one, or everything together? Joanna's got a comment. Is there a way to make Control-C and Control-V for copy-paste work on the cloud? Try Control-Shift-V for a paste. Control-C should work, but Control-Shift-V might work. If not, I don't know actually. Does anyone else know if the cloud it's got a way around Control-V? Not entirely sure, I'm afraid. You might have to just do some tippy typing. Okay. So let's talk about joining tables without keys. So when you're joining two tables together, let's say you had a table that had a list of patients in it and their addresses, and then you wanted to join that to a list of those same patients, a table of those same patients that had some kind of medical information in it, and you wanted to join those two things together. You would know that the patient code in the table 1 is the same as patient code in table 2. So that patient code column would be the key that you would join them on. We're not talking about joining tables with keys at the moment, okay? We're talking about joining tables that don't have keys. So let's go through this then. We're going to create a new object called df_1, and it is the data set. Then we're going to select these, and then we're going to, these columns. Then we're going to do head. So hopefully you remember that head with no arguments in it will give us the first 5 rows. So df1 will now be in our environment as a little data frame. So we've got these, I don't know why it's giving us 6 rows instead of 5, never mind. So we've got the top essentially of the data frame with only these 4 columns in it. Let's make another data set called df2. We're going to select all the columns where it is numeric and take the head of it again. So the top 5 rows. So we'll have df2 here, again, 6 rows of 3 variables now, because there are 3 numeric variables in the data set. We're going to combine them together. And cbind is the way we're going to do this. So cbind is column bind. So we're going to take the columns from this one and the columns from this one, we're going to smoosh them together, whether they match on anything or not, okay? So we're just sitting them side by side. We know that they've got the same number of rows in them, so it shouldn't complain to us about this. So yep, if we run this df new on line 316, we get a df new thing, which has the original data set and the second data set, and we've just smushed them together. Now you'll see what's happened here is we've got 2 versions of the attendances column, because we had one in our df1 and one in our df2. So what R has done is it's added a little suffix to the name of the incoming version so that we can disambiguate them. They happen to be the same data here, but it'll create this disambiguation by putting dot something on the end, on the suffix of the name, if you join them like this. Yeah, so that if we were joining these and we wanted the attendances column to be the key that we join them on, we could do that. There's reasons not to do that, but we'll not talk about that just now. Yeah, you need to be mindful that you have rows that line up. Yeah, so again, we're just smushing these columns together no matter what's in them, okay? And that's not always the way you want to do it. It's not always a sensible thing to do unless you're very, very sure that the order of observations is the same in both data sets. We can also bind data by rows. So let's remake df1 and df2 by just taking some of the rows, the top 5 rows, the bottom 5 rows, and then we just combine these using row bind. So similar to cbind for columns, rbind is just going to smush the rows together. So when you're combining columns with cbind, you need them to be of the same length, same number of rows each. And similarly, when you're binding rows together, you need them to have the same number of columns each, otherwise it won't quite know how to match them up. But because we've got both of these, which are taking a slice of the original data set, they should both have exactly the same columns in them. So let's run df new here and have a quick look at it. You can see here that it's combined the 6 rows of each of these into 12 observations, 12 rows, and we've still got the same 6 columns. So that seems like it's done the right thing. So we've just smushed together based on rows those 2 mini data sets that we had. If we don't have matching columns, we can use a thing called bind rows. And it's a little bit cleverer than rbind, essentially. So it matches columns where they match in terms of their name and puts an NA in for those that don't match. So let's remake df1, which again was that subset of the columns that we had and the subset of rows. And we'll do df2 as that as well. And then we'll use bind rows, which let's F1 it just to read about it a little bit in the help. It comes from dplyr. Bind any number of data frames by row, making a longer result. And there's other ways of doing this, like with do call. The output contains all the columns that appear in any of the inputs. Okay, so that's nice and clear. So let's run df new and see what it looks like. So here we've got 12 observations now because we've bounded the rows together, and we've got 6 columns. So you see we had different number of columns in 1 and 2, and what it's given us is all of the unique columns that existed in either of those. That's 6 columns in total. We can do it nicely in a pipe as well. So I do everything in a pipe because it's the way my brain works. It's this thing, df new, is this thing, then bind the rows to df2. So when you're doing it in this way, you're using this first object and passing it to the second object. So if you were doing a left join, this would be your left and this would be your right, because this one comes first and this one comes second. That might not make sense to you if you've not done left joins, but hopefully it does to some people in the room. So, and it'll do exactly the same thing. So it hasn't changed anything about the df new table. It's just a different way of writing that flow. Okay, so that's how we can quick and dirty bind some things together, some data sets together that don't have a key. But bind rows is the way that we can do it, where it will be a little bit more clever about the identically named column names. So any questions about those things? Everyone happy about the C bind, R bind, bind rows? There is a bind calls as well, in case you were wondering. Cool. So another over to you here. Can you please create a data frame of the top 5 admissions only and the bottom 5 attendances only, and join the 2 columns together? Does that make sense to everybody, that instruction? So it's only 1 column in each. Top 5 admissions and the top 5 attendances, and then join the columns together. See what you can get. I'll give you till 10:16 to do that. And as usual, thumbs up when you think you've done. There's a little bit more typing to be done with this one, so it'll take you a little bit longer. Right, anyone managed to do that? Need a little bit more time? Let's talk it through together. Share screen. Okay, so let's do it the way we've been doing it so far, quite overtly creating 2 new things that we then stitch together. So let's create a data frame called df1, but that will be, as we were talking about, the top 5 admissions only. So take data, then select only the admissions column, then remember our top n function, we want the top 5 based on admissions. We want the highest 5 admissions rows and only the admissions column. So let's just run that and just check that that looks okay. df1 is this one. Yep, that looks all right to me. Then let's create the second part, which was the bottom 5 attendances. So hopefully this is quite obvious now. Here's data, then select, and I'll just do, I can't spell attendance as well, just let it autofill for me. Then the top n, and as you remember, if we do a negative number, this will take it as the lowest in whatever. So we're going to do the lowest 5 based on attendances. Okay, and let's convince ourselves that DF2 looks right. Yep, the 5 lowest attendances. Then let's smush them together. So let's bind them together with bind calls. So the new data set will be bind calls, and DF1 is our left one, and DF2 is our right column. And DF new will then look like this. So we've got the highest 5 admissions and the lowest 5 attendances smushed together into one little data frame. Everybody follow along okay with that? We'll go for another 10 minutes and then we'll have a break, I think, okay? Okay. So the binding we've done just there has all, as we said, been predicated on the idea that if you're binding columns, those columns have to have the same number of rows. If you're binding rows, they have to have the same number of columns. That's not always going to be the case. So let's look at doing things where you have different number of columns or different number of rows. Now, this is an instance where you'd want to use those join functions that I was talking about that come from dplyr as well. They're really, really useful. So we're going to rename branches to admissions to create some duplicates. So we're going to take df1 is going to now be data, this org code, and then this admissions column, which is actually going to be the breaches. So we're going to create a column called admissions, which was the breaches column. It's a bit confusing. And then we're going to do the same thing, but actually keep the admissions column for df2. We can do a union here. So let's f1 on union and see. So this is interesting. So union is a function that there's at least 4 different types of union in the dplyr base, in generics, and then lubridate, which are all good functions. So let's look at the dplyr version. So in the dplyr package, the set operations has got these different things. So this is all comparing one set of something to another set of something. So the union between X and Y finds all the rows in either X or Y. It excludes duplicates. Let's have a look at the union. df new union is all of these in here. Okay. Let's find the identical columns in the both tables. So the intersect is how we do that. Okay, and intersect I think was one of these as well, wasn't it? Yeah, intersect is all the rows that exist in both X and Y. So which rows exist in both df1 and in df2? 427 of them. So these rows exist in both the data sets that we were looking at. Okay, so it's brought them together. Set diff is the one that I use a lot. Set diff is really useful if you've got, and so the times I use set diff are when, for instance, I'm working with local authorities, and you know how local authorities merge and split and do all sorts of silly things over time. If you want to convince yourself of which local authority codes exist in table B that don't exist in table A, for example, you can use set diff, which is really, really helpful. So set df new diff will now be 7,000 long, and these are all the differences there are between our df1 and our df2 that we just created. So that's a lot of things I've just shown you there. So we've got union and intersect and set diff. They all come from the same place, essentially. They're all looking at differences between 2 sets of things. So that's a nice way of understanding the associations between your data frames. And set diff is definitely one I use the most. Time you're on 20 past. Any questions on that little section before we move on to mutating and summarizing? Again, impossible to know if I'm going too fast or too slow for you guys. So please do let me know in the chat or raise a hand or something. Right then. Ooh,
sorry, just one question. Is there a way to do that, but only looking at specific variables?
Which one, sorry?
So if you wanted to look at so if you had more columns and you wanted to say, can you show me the ones which have a value that's different in this column?
Yes, it definitely is. Whether you can do it with these specific ones or not, I'm not completely sure. I don't usually use these ones. But I'm pretty sure with set diff, instead of specifying the entirety of the X of one of the data sets, you could have X $org code, and then you'd have Y $org code as well. So you can specify the column name that way. Alternatively, you could create new data frames that were just the columns you wanted to do and run these as they are here. Probably 18 different ways of doing it, to be honest. Just see if I've done it down here in the examples anywhere. Yeah, they've just compared whole data sets here, so it's not very helpful. But that's a really good Google one, because yes, you absolutely can do it based on a subset of columns, but it's not in the help. So I would look in the Google.
Okay, thanks.
All right. Okay. Is there a question? SetDiff's working on all of the columns. Is the answer to that. So I use SetDiff, like I say, with columns that are factors. So I'll often give it. So if I do $1 on the end of here, we've got org code. $2. We've also got org code. See, so what I'm doing here is taking the set of org codes in DF1 and the set of org codes in DF2, and I'm asking it to tell me which ones are different. So if I just put them here, it should give us, these are the ones that exist in the DF1 but not in DF2. The order of these matters. So if we change them round, it would be doing which are the ones that exist in 2 but not in 1, whichever was the opposite way if I just said that. Does that make sense? Let me say that again. So what SetDiff is doing is saying, of all these, how many of them are not also in here? The difference between these two sets. So you can see that would be these ones, 274 different factor levels exist in DF1 that don't exist in DF2. If you changed around the order of these, so that you did DF2 here and then 1 here, it would be the opposite. It would be how many exist in 2 but not in 1. It's so much easier to do that and to look at it rather than try to explain it in words. So sorry if I've just confused you more, but that's how I would do it if I'm looking in a particular factor column. But SetDiff itself is working on all of the elements within the data frame. Right, let's move on to mutate and summarize. Yeah, again, this might be quite familiar to a lot of you and it might not. So there's lots of different ways of summarizing a data set, and the summarize function with the dplyr, you can use an S or you can use a Z, it doesn't really matter. It can take the US or the English spelling of summarize. What we're doing here is we're creating something called data old, which is assigned to take the data frame, group it by the type column. I mean, remember that type column. Let's look at data again, just to remind you. Type column is this 1, 2, other column. So each element of the type column, the ones, the twos, and the others, is a different group. Then summarize those groups by creating something called count, which is n, and this little function is the number of rows. And then ungroup. So this was the way you would write it if you wanted to do something for every group, for every one of those type things, for the ones, the twos, and the others, create a count of rows. Okay, so let's do it like this. The data old is here. So we would expect a row for every different level of that factor. So type has got 3 levels, 1, 2, and other. And what we asked for a row count for each of those. So there were 4,900 of ones, 1,100 of twos, and 7,000-ish of others. That is how I learned to do it, doing group by on its own line. But these days, it's not very new anymore, actually, but I still do it the old way, which works fine. You can do it within the summarize function. So, oh God, it's even spelled it in. That's awful, isn't it? Take data, summarize it, creating, again, a count, and then you actually pass it the .by argument, and you give it the column name you want to do the summarizing by. If you don't do that, it will just do the whole table. If you don't submit a .by or a group by before you summarize, it will do the whole table. It will give you the number of rows of the whole table, because n is the number of rows. Does that make sense to everybody? Does everybody know what I'm doing there, why I'm doing it? Ruth?
Let's just go a quick question. With the new school version, do you need to ungroup as
No.
well?
No, and that's one of the benefits as well. So it's cutting out 2 lines of code. Remember, we're all lazy, so the fewer types on the keyboard we can do, the better. So you are better off doing it this way because it's grouping on the fly. It's not grouping. It's not changing the feature of that actual data frame to be a grouped data frame. So unless you run ungroup after doing it this way, that table, the data old table, is now a grouped data table. So everything will run on it in a grouped way. So that might give you answers that you don't expect unless you remember that you grouped it. So you need to remember to ungroup it. But doing it this way, it doesn't do that. It just does it on the fly. And so it retains its ungrouped status, which is a bit nicer, actually.
Yeah, that's handy.
Yeah. Okay. So here we've got a mutate. So hopefully everybody knows mutate in dplyr land means create a new column. And we can create a new column on the fly based on what's already in the data set. So data old would be take the data, then group it by type, then mutate, make this new column called double admissions. And what that is the admissions column multiplied by 2, and then remember to ungroup it again. But again, instead of doing this group by and then ungroup, we can actually just pass the dot by to the mutate, and it will do as it says on the tin. So let's just run this to make sure. Data new. And you can see data new, actually you can't because it would have overwritten it. It'll give you the exact same table as we did it before with the group and the ungroup. But it's doing it this time based on this dot by instead. So we've got a double admissions column here, which is the admissions multiplied by 2, which is nice. Delete these, keep things nice and clean. Right. I think before we go on to functions and stuff, we should take a bit of a break. Any questions on that bit before we move on? No? Lovely. Okay, so what do we want? 10 minutes, 15 minutes? Take 15 minutes? If we take a longer one this time, then maybe we take a shorter break at 12. It's up to you guys. If you're exhausted, it's absolutely fine. We can take a longer break. But I would suggest we do 15 minutes maybe this time. Thumbs up if that works for you. Get a cup of tea. Brilliant. Okay, right. We'll be back then at 11:45 and we'll carry on with the functions. Thanks, guys. Hello, everybody. Hopefully everybody's filtered back in. Okay, so we're going to continue with what we were doing earlier on. Again, if you've got any questions, if you want this to be going faster or to be going slower, do pop something in the chat or pop your hand up. I will continue at the rate I was going before, if that's okay with everybody, unless told otherwise. So again, please do interact. The more you get out, the more you put in, the more you get out. Hopefully, even if a lot of this stuff is familiar to you already, you're finding a couple of little useful things that'll up your game. There will be a feedback form coming out after this, I think. So please do pop in there any feedback you have for us. Right, let's move on to the next stage. So we're picking back up from roughly line 429. If you're working in Posit Cloud and you've been away for a wee while, you might need to wake up your project. There's a resume button or whatever it's called that will take you back into where you are. So roughly line 430, we're on to count functions. Yeah, and we'll be using dplyr again to do this. So remember the table function that we used earlier on, which basically counts things for us. We can do that using dplyr instead as well. So we can create an object called data count, whereby we just count based on type. Okay, this is really nice, small syntax to create a new thing. So running this will create an observation of 3 rows, which I'm hoping you would expect because we're doing it by type, which remember has only these 3 different possible entries, 1, 2, and other. So again, it's counted something for us, and it's called this n because n with brackets is counting the number of rows. You could write this in exactly this way as well, which is doing exactly the same thing, where you would take data, you would run summarize, and we want to summarize creating something called count, which is the number of rows by the type column. So these lines 438, 439 do exactly the same thing as 442. But again, we want to get as efficient as we can with our coding. So that's a nice shorter way of doing it. Add count adds a new column to do this. So it creates a new column like a mutate with a count by feature. For example, how many times has an org code been submitted? How many times does it appear in this data set? So add count will pop it on the end here for you. And again, it's called n because n is the shortcut, if you like, to number of rows. So you'll see these numbers repeated because RF4 is an organization code that happens 108 times. So every time it sees RF4, it will say 108. R1H also happens 108 times, but you can see code AD913 is on 36 of the rows and RYX is on 36 of the rows. So this is the number of rows for each organization code. And this can also be written with the .by instead. So we can do it this way where we take the data frame, we mutate as in make a new column called count, which is the number of rows for each type. And it will do, well, actually that should be org code, shouldn't it? Org code. So let's just check that we are happy we're doing the same thing here. So this is how it is originally, the 108s, the 36s, etc. And let's do it again. The 108s and 36s. Okay, so I'm convinced that this is doing exactly the same thing as this. There's no, I mean, it's not wrong to write out more verbose code if that helps you. So code needs to be efficient and effective. It needs to work, but it also needs to be human readable to a degree, which is why R is nicer than some other languages because it does make things quite human readable. The more human readable it is, the more easy to debug it is as well. So there is a functional aspect to how you write what you write. If you find this syntax much more easy to understand what it should be doing than this one, then that's part of the decision-making process, and that's absolutely fine. Right, let's move on to filtering. So in dplyr, we know that select is talking about columns. Filter is always talking about rows. So we're talking about taking a subset of the rows from a data frame or from a tibble. So we've got a nice little function here called string detect. Let's F1 it to see which package it comes from. String detect comes from the stringer package. So if you haven't already got it, you might need to load it. I can't remember if we did at the beginning. So what we're doing here is we're creating an object called data filter, which is our original data frame. Then we're going to filter as in take the rows where we detect the string in the column org code that has R in it. See what that does. Data filter is here. So within R code, org code, it's going to bring us all of the data that has an R anywhere in its organization code. We haven't specified where the R is, whether it's in the middle, the end, the beginning of the string that's in here. It just has an R in it. So it has detected that there's an R in the organization code, and it's giving us only those rows back. This one filters data to the latest date period per organization. Okay, so take the data filter thing that we're going to make. It's data, filter it where in period, which is one of our columns, is exactly equal to the maximum that we find in here. So the maximum of period, if we pop this down here and we have data dollar. So what we're saying, what is the maximum in this period column? And it's 2019-03-01. So we want to only take rows where the period column happens to be that maximum period, and we don't have to restate the data dollar here because we're already talking, or piped it, so we're already talking about that data set, so it knows that we're talking about data dollar period. And again, we'll do this by organization code. So this is nice and powerful. We're not having to figure out what the maximum date is for each organization code ourselves. It's doing it for us on the fly with just 3 little bits of code. So, and this is what it looks like if you've run that piece of code as well. So these dates will be different because for each code, it'll be the maximum date that existed on a line with that code in it. So it's not just the maximum overall code, maximum period overall. Another way of working is we can, again, double equals in R. So one equals generally means, you can think of it in English like it means is. And it's another way of assigning things as well. So instead of doing this assignment operator, you can just write equals. This is more clear. But double equals means exactly equal to. There's a nuance there, and you'll come up against this. Sometimes you'll get comfortable with when it needs to be a double equals. So here we're saying data filter is going to be take the data frame, then take the rows, because we're talking filter, where type is exactly equal to 1, comma, which means also attendance is more than 10,000. So here we've got 2 different qualifiers for understanding which rows we want to bring back, and we've just combined them with a comma, which will link them. So we're saying we want all the rows that are both of that meet both of these arguments. So that will be this many rows. So data filter is 1,621 rows long now of 6 variables. So what was it? Attendance had to be over 10,000, didn't it? So you can see that all of these attendances are over 10,000. What's the other thing? And it's only type 1. So you can see it's only type 1s as well. Or in R, so this is quietly saying and. This is saying the type has to be 1 and the attendances have to be over 10,000. If we want or, we do the pipe, and this is actually called a pipe. It's not the same as this kind of pipe, but this pipe symbol again is shift and then the button right beside shift on most keyboards. So here we're saying bring me the rows that the type is 1 or the attendances are over 10,000. So just remember that with this and we've got 1,600 rows. You can imagine that this, if we run this, it'll be more than that because it's not just taking the rows where both of these conditions are met, it's taking the rows where either of these conditions is met. So let's see what happens to the data filter. Yep, and it's gone up to 5,000 rows. So you can combine arguments based on whatever combinations you like here, and it'll bring back the rows that meet those conditions. And you can have them relatively complicated as well. So you can have them combined in brackets as well. If you've got type 1 and this, and also or this. So these can get quite complicated if you want them to. But hopefully you can see there how you can combine different not arguments, different conditions within your filtering. So you're bringing back exactly the rows that you want. So based on what we've just done, can you write a script to check if we have run 1 row per org code? And if we don't, give us back only those rows where we have more than 1 row. Only those organization codes where we have more than 1 row. And if you can, for bonus points, put them in order of the number of rows. You should be able to do all of this with the functions that we've just looked at. So I'll give you a little bit longer for this. I'll give you 3 or 4 minutes for this. Any questions before I stop sharing screen? Everybody got to that point? Oh, I'll give you 3 or 4 minutes to try and do this. Don't worry if you don't get to the bonus points bit, but have a go at the first 2 elements. For those who are cheating and looking at the answers as well, there is a hint I can give you, which is to have a look at what else the count function can do. So bring up the count help file and just see if anything else that you can do with the count function could help you with this task. Right, let's put back together. Anyone manage to do that task? Anyone got stuck or found that difficult? Or would you like more time? Silence is good news. Okay, let's share screen and then see how we can get back to this. Okie doke. So the hint I gave you there was to have a look at the count help file and see if it can do anything useful for you. So let's do $count here to bring up the help file. We've got an argument we can pass it, which says sort. Now this does what it says on the tin, as our stuff generally does. So we could pass this argument to say, do sort this as well. So what we can do is let's create a new thing called data filter, as we've been doing all the way through. That would be the data set that we've been using. We will count organization codes, and we'll pass it that new argument sort equals, and we'll give it true. So when you're doing true or false in R, it's all caps. That'll let R know that this is a Boolean function, which is the one or the zero, the yes or the no, true or false. And then let's filter those rows to where the number of rows is greater than 1. We usually put spaces around the arguments there. So again, you might have got to this answer in a completely different way. As long as you got to the answer, that's absolutely fine. So let's see if this works. Need to filter is here. So we've now got, as long as there was an organization code that had more than one row in it, it's giving us all of those, and they are sorted in descending order. Okay, did everybody get that or something like it? Anyone struggling? Ben? Oh, you're right. Okay, good. That's fine. Okay, good. Hopefully you're getting an idea of how flexible some of this stuff can be and how you can start to create quite complicated but simple looking actions that are quite powerful with dplyr. Okay, so let's talk about conditionals now. So the if-else kind of statements. And again, some of you might have done loads of this before, so apologies if you have, but let's go over it anyway for your consolidation of that knowledge. So let's flag all the instances where attendances were above 20,000 using a simple if-else statement. So if-else is written if underscore else, just to make that useful. And it's talking about if attendances are over 20,000, then the above 20,000 will be a y, otherwise it will be a n. Okay. So this is the syntax you can do with an if underscore else statement. So we're going to overwrite data at this point. We're going to say this data is now what data was, create a new column, which is called above 20,000. What goes in that column is a yes if attendances were over 20,000 and a y or an n if they're not. Have a look at what that looks like. Oops. Dead. Did it function instead? Right. And this is what we have now. So remember, we've got our new column because we mutated a new column onto the end. And it's got yeses and nos in it, depending on whether the attendances were over 20,000. Yeah, so we can verify that, yeah, looks like it's done the right thing here. Over 20,000 gives a y. Y. Sorry, I have kids. Y. It's what my brain says. Okay, and see there's only two of them in the top half of this table here. So we've got this one that's 21,000 and 30,000. It's got a y in both of those rows. Yeah, so this will flag an issue if you are trying to give a number sometimes and a text string other times. So, for example, if you were creating this above 20,000 column again, you're saying if the attendances is over or equal to 20,000, give me the number 100. Otherwise, give me this string, and it knows it's a string because it's with 9999. Okay, so what we've said here is that in one instance, give me a number, but in another instance, give me a string. It's not going to like that because that's mixing types within the column, and that's not what tidy data should be. So let's run it and see the way in which it conflames. So it's saying error in mutate in the argument above. This is where the error occurred. It's caused by an error in if else. Yes, it is. It can't combine true, which is double, and false, which is character. Okay, so the true and the false are coming from the fact that it's an if else statement. So if else statements are written as if argument, true, false. So it's telling us here that in our true instance, it would give us a double because we've said 100, which is a double is another type of number essentially. And we've set a character. It doesn't like that, so it's given us an error and it said no. Okay. So you just need to make sure that the things you're giving it for the yes and the no are the same data type, class as it is. If you're not sure what the class is of something, let's there is a class function, funnily enough. So you can run a class and put the thing in. So if I put class with the 100 in, it'll tell me it's numeric. If I put class with 9,000 in, it'll tell me it's character. So if you want to quickly check what class it is to see if they match, you can use the class function. You could even write a class of thing X is exactly, rather than say it, let me do it. So let's call a new thing X is 100, Y is 9,000. Okay, so let's say class of X is equal to class of Y. This should say false. Yeah, because we know the classes are not the same. We've just created X as a number and Y as a string. So classes are not the same. Okay, so classes are useful, but it's written in these scripts. But if you're wondering whether there's a difference in class causing this issue, that's how you can have a look. Okay, if else is great for a single conditional. You can nest if else statements, but it gets really messy really quickly. It looks hard to read, so it's not nice. What we can do is the case when instead. So if else is fine, it works as you've seen, but case underscore when is a better way of doing it if you've got lots of different statements you want to evaluate. So let's do this. So we're going to mutate attendance grouping. Okay, we're going to create a column called attendance grouping, and that is not is exactly equal to, that is the case when if attendances are less than 5,000, then we want in those rows to put the string less than 5,000, and so on and so on. Any rows that don't match one of these arguments, you will be given what you put by dot default. So the default is if you've got rows that aren't less than any of these, then it'll give it this value. It'll say over 25,000. A really bad way of saying that in English. Sorry. I can say that again if anybody didn't get that. So case when is really useful for multiple arguments, multi-part conditionals is what he's called it up here. So attendance grouping will be, well, what will attendance be grouping? Depends. On rows where attendance is less than 5,000, it'll say less than 5,000, etc., 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 until it has rows that don't meet any of these conditions, and then it will give you the default, which will be over 25,000. So it's a nicer way to write the nested if-else statements. Nested if-else statements would be like, if else the attendance is less than 5,000, say less than 5,000, and then instead of false being something, you'd have the next if-else as the false statement, which is sort of like saying, if it's less than 5,000, say less than 5,000. Otherwise, if it's less than, and this gets really long, really jumbled, and it's very difficult to read, whereas case one is much, much cleaner, much nicer to read, and much easier to debug as well. Let's run that a little bit. Okay, so we've got all this string column here. So this is all words, so it'll be evaluated as words, not as numbers, and it's based on the arguments that we gave it. So it's a nice way of having a multi-conditional, or whatever it is you call it. Yeah, so the default is the else. Do this, else do this. The tilde, this wibble, it can be found as a shift dollar next to the return key. Yes, so you'll see it right next to your enter key there, and that is what you're assigning to the rows where the condition is met. Old school way of doing this. Yeah, so I've never done it this way. This is just instead of dot default, it used to be true. So true is just a way of saying the exception to all of these would have the over 25,000 element in it. Any questions on case when? Yeah, and so in case when it'll complain if you do equals. So attendance less than 5,000 equals less than 5,000 won't work, and it will complain. So you need to use the tilde in case when, but it does make it easy to read, especially if you put them on each on a different line, right? It's nice and clear. And dot default is the more modern method. Okay, let's make a deliberate issue. So for example, this case statement fails if we have a value of exactly 25,000. So what we're saying is in the data object, column called attendances, the first item within that is 25,000. Okay, so currently the first attendance is 21,289, but we're going to make it 25,000. Okay, so we've overwritten that as 25,000 here. Now let's rerun the above case statement. So it's not less than 25,000, it is 25,000. So let's see what it does when we run this again. Data. It's saying over 25,000, which is not correct. And let's add some null data as well. So the second element in the data column is now going to be NA. We've created an NA, which is just a blank, essentially. And again, the case statement works, but it's not actually correct. So it's saying NA is over 25,000, which it isn't, obviously. Yeah. So he likes the true statement, as an error catch. Okay, so instead of having, if you know that you want things over 25,000 to say over 25,000, be specific about that and make the default something else, so as that you know all your rows should have one of these. If they don't, then you want it to show up as an error. So let's run this. And we can see now that that's doing the right thing. A value of 25,000 doesn't actually fall within any of our specifications, and an NA doesn't either. A little word of warning with NA. NA in R is often treated as an infinite number. So if you're doing evaluation statements that is saying, is NA bigger than whatever number, it'll say true in some instances, because it's using NA shorthand to mean a really big number or blank. So we can be a bit more specific about these case statements to avoid needing to do this by doing is greater than or equals to and changing a grouping description. Okay, so we could do that here to make that a little bit clearer, so that we are going to actually group our rows the way that we want to. Okay, I've got a little task for you to do. Can you please, with our data, add a column that if type 1, if the type is 1, then it halves the attendances. If the type is 2, it triples them. If the type is other, it multiplies by 4, quads the attendances. And if it's none of those, then we want a suitable error bit of text on the end there, please. So have a go at that. Where are we? I'll give you till 11:15 to do that. So that's about 3 minutes. Have a go.
Silly question. What does quads mean? Is that times by 4, or is that some other
Yeah, that's a Simonism. Yes.
Okay.
Just multiply by 4. Okay, anybody not managed to do that? Anybody struggling or confused?
Getting an error, but I think I'm close, so it'll be interesting to see what you get.
Okay, so I'm gonna cheat and copy in the whole of the answer here because you don't need to see me misspell things a million times. So this is one of the ways you could do this, okay? So here we've got the data that we're going to overwrite as the data as it originally was. We'll mutate a new column called attendance multiplier, attendance, whoop, see I can't spell, attendance multiplier. And that is going to be the case when if type is 1 in speech marks, single speech marks. Remember, R doesn't mind if you use double or single speech marks, provided you're the same on either side of the string. In the case where the type is 1, then attendances is going to be halved. If the case where the type is 2, attendances is going to be tripled, and the type is other, it's going to be quadrupled. And dot default here is going to have to be a number because we're giving it numbers. So we can't have a message in here because then it would complain at us again that we're not using the right types, data types as we did before. So let's run this. So we've got an attendance multiplier here. We've got an NA on the NA line because we didn't tell her what to do with NAs. And I don't think we'll have any treble nines. So there's problems with this answer, right? And the problem is that we're not getting an error message and we're giving a number, a minus 9999. That might be fine as a number because it would be completely implausible in your data. However, if the numeric column that you're working with minus 9,999 is a plausible number, then you'd want to not have that. Okay, so you could have it as NA as long as you will then know that those rows are not missing deliberately, as it were. So you have to think a bit more carefully about what you want to be in there when the conditions are not met. So Lauren, is this kind of probably what was going on with yours?
A couple of things. I think I'd spelled attendances without the S. I'd used a slash for divide instead of a times 0.5. And yeah, I put text as my dot default. So multiple issues, but I understand why it didn't work now.
Okay, cool. That's good. Yeah, the spelling thing. So if you're not sure, then the autocomplete is really, really useful. So just do the first 3 or 4 letters and it'll give you options as to what you might have meant. Because I cannot spell, so it's helpful to use. Any questions on that? Does everybody get to something along those lines? Or I understand where I'm coming from with the things I'm saying there? Yes, of course you could, Emma. Do you want to share your screen?
Yeah, sure.
Okay.
Is it just the typo in default?
Yes. See?
Lovely, thank you.
Live coding. Brilliant. Well done. That's really useful. Thank you for doing that. Yeah. Yes, that was a relatively sensible error message that pointed you in the right direction. So that's good. Okay. So there is an if function in base R that we can use as well. It allows you to do a one-sided statement if you want to trigger a conditional process. Rather than have an if else, you can just do if and nothing happens in the else scenario, if you like. So curly brackets denote a scope, and what that means.
You want to share your screen again?
Oh, am I not sharing my screen? Yes, sorry. How many times now? Twice today. I'm doing all right, less than usual. You should just have a button that makes a horrible noise at me every time I forget to do that. So we're moving on to this section starting at line 602. So follow along with us. Yeah, so the if statement is in base R, so you don't need to load a package to use an if statement. And the curly brackets that come after it here, they denote what happens if this condition is met. Okay, so by the way, useful thing in R, if you can't find the other bracket that matches the one you're on, you can double click on it and it will highlight everything that's between those 2 brackets of any bracket type. So if I double click on this one, it'll show me everything that's between those 2 brackets. Just clicking on it will highlight them in grey. If you've got huge functions, it's not necessarily as easy to see, but if you're not sure where the next one is, double click on it. Okay, so first what we're going to do is we're going to assign the value of 5 to something called A. So you'll see this come up in your environment. There's a thing that we've created that's called A that happens to have the value of 5. We're going to use an if statement here, a little bit of an if function. So we're going to say if A is exactly equal to 5, then do all the stuff within this scope. So the things we're going to ask it to do is we're going to change A to 10, print the words A is now 10. We're going to create something called B that is the same as A, and then we're going to print B has been created as a variable and is now A. So that's all a bit confusing. Let's run it and see what happens. Okay, so you can see in our values over here in our environment, the A did start off as 5, it's now 10, because within our scope of our if statement, we have reassigned it as 10. So we've overwritten it, okay? And it has created these little text outputs that we asked it to. It's printed A is now 10. And then when it got down to here, it printed B is now being created as a variable and is now A, as you can see here. Okay, so an if statement can be useful if it doesn't always have to affect anything in the environment necessarily. So this is really powerful as it works by if condition in brackets is met. Yeah, so that's badly written, but yeah, it's what we're doing is asking it to do everything that happens within the curly brackets if the condition is true. So if A is exactly equal to 5, then do all of this. So let's put A back to 5 again. We'll see in our environment over here, A is gone back to being 5 because we said so. And in the case where A is exactly equal to 5, we then want to do all of this. We're going to create a thing called C. We're going to print that. We're then going to close this bracket because if can have an else attached to it. You didn't have to have one as we didn't up here, but we can link this saying if A is equal to 5, do all this. If it isn't, else, do everything that happens in this scope. Okay. So let's run this and see what happens. A is 5 currently. So what we should expect is that it'll do everything in this first set of curly brackets because this argument is true. A currently is exactly equal to 5. So it has printed A is now 10 and it has created C as the same thing as A and printed C has been created as a variable and is now A. I wouldn't call it a variable actually, it's a scalar, but never mind. If we ran this again right now, because part of what we did was change A to 10, we should then get these things printed out instead. So let's run it again just to be sure that it's not going to do the same thing again. So what we asked it to do, if A isn't 5, which it isn't anymore, it's actually got a value of 10, is to print these two things pasted together. So a paste 0. Has everybody come across paste and paste 0 as functions before? If not, give me a shout. So they do what they say on the tin. Paste 0 just sticks two things together without a space between them. So it's sticking together this string, A is, then space, and they're combining that with A, which would be the value of A, which is currently 10. So this is why it's printed out A is 10. And then C does not exist. C does exist, but we're printing out the words C does not exist. Okay. So we've run exactly the same code twice, but because we changed the value of A in the global environment in the first part, it's now going to evaluate the else statement instead. That's a little bit nuanced. Does everybody get that? Has everybody followed along with that? Anyone want to see me do that again? We're doing silly little things here, which can be a bit confusing, but actually this is a really powerful, really useful thing to be doing. And it's the start of you writing your own functions. Okay, we're going to go back to looking, grouping and mutating to make subtotals. So grouping and mutating rather than summarizing is a different way of going about things. So we want to calculate the total and the percentages by month and by organization code. So let's create total number of attendances across all types by organization and month. We'll create a new data frame called data tot_perc, total percent, which is the data originally, and then mutate two different variables. We'll mutate total attendances, which is a sum of the column attendances, so add all of the attendances up, and the percentage of the attendances, which is attendances divided by this new thing that we've created, multiplied by 100 to make it a percent. We'll do all of this within each organization code and period. Okay, so that's quite a lot to take in there. That's doing a lot of different things on the fly. it's creating a variable %attend, which already uses a variable that we created one line before, which is definitely an improvement on things that you know, SQL can do, for example. And we're doing all this with the .by statement, meaning we're doing it all for each group that is each distinct organization code and period combination. So let's run it and see what the output it gives us. Total % here. So we've got the total attendances and the total percentages on the end here. We've created these two variables. And the % it's got a lot of significant figures here. We can fix that to make it look nicer if we want to. But this is the percentage that we were talking about that we've created. So you can see how that's quite powerful, yeah? So you can use the variables that you've just created one line before to do something with it and create a percentage on the fly and do it for each group. And that's summarizing your whole data set without using the summarize function down into a total attendances and a percentage attendances within each organization code and period. And that is why it looks like this. No, like this. You'll see this in the total attendances column. We're having repetition here, and that is expected because what we're doing is we're doing it within each combination of these. Each combination of organization code and period might happen multiple times. So that's why we're getting the same value of total attendances for a number of different rows. So that's quite a lot to take in. Sorry, that feels like a jump, doesn't it, that one? Okay, that creates a pretty long decimal as a percentage. So can you round it to 1 decimal place? So yeah, use your Google foo. Go and have a Google or use a function that you know of that you can use to round all of the values in that last %attend column to 1 decimal place. I'll give you 2 minutes to do that, or give me a thumbs up if you've done it more quickly. Mark? That's been about 2 minutes, I think. Everybody there? Everybody rounded their column? Look at me remembering to share my screen again. Right. So the easiest way to create the column already rounded, let's copy this. Pop it down here. So it was this percentage attendances column that wasn't looking very neatly. So if we wanted to create the rounded variable to begin with, we can wrap all of this in a rounding function. So let's type round, open a bracket, and then end this with a bracket as well. So everything within the bracket is going to be rounded. And with the round function, the thing you want to round comes first, and then the argument after a comma is how many decimal places you want it to round to. So let's say 1 decimal place. I hope you all found the round function. I hope some of you just guessed it because R is sensible and calls rounding round. Let's see if that works. So now we've got 1 decimal place. We've got these percentages looking a little bit more sensible in our data frame. Obviously, as analysts, we know not to round things until we are presenting them. We don't round them before we've presented them in whatever report or whatnot is going to be used. So Any questions about that? Did everybody manage to find a way to do that? And it's fine if you had this data frame and then after you'd created it, you rounded that column as well. So you could have mutated and said %attend is a round of %attend. That would be one way of doing it. Does anyone have a completely different way of doing that and wants to share their screen and show us what they did? No worries. Round is the easiest way to do that, probably. But there will be others, no doubt there will be others. If at any point during these today and tomorrow, this training, you have other ways of doing things that you think are better, please let me know. I don't doubt that there will be some. Okay, say that we wanted to do that on all our numeric data. So there's a really nice function called across, that's again from dplyr, that allows us to do pretty fancy stuff. It's starting to look a bit ugly, this code, isn't it? It's starting to look a bit SQL. Sorry to the SQL coders in the room. I'm not a fan, just because it looks like a little bit gobbledygook, but let's talk it through anyway. So we're going to create data top perk again from data, and we're going to create a new column, mutate a new column. And this is going to be across all the columns where they are numeric. And in those, tilde means in those, we're going to take whatever is in it, divide it by the sum of whatever is in it, and multiply that by 100. The names we're going to create for these new columns. So again, this is going to be doing this to multiple columns. It's going to be, so that we say dot names is, and we wrap it in these speech marks, %_, and then it'll be the column name that we're on at the time. And we do that by having them in curly brackets, and dot col is whatever column it is. So it'll have a perk _ prefix to every new column name that we make. We'll do this for each combination of organization code and period. So that's pretty complicated. Let's have a look at it. So for every numeric column, we've got 3 numeric columns. These are the originals, aren't they? Here's some nonsense that we've created. So, oh no, 4 numeric columns. So we've now created 4 new columns because we've gone for all the numeric columns that there were, create me a new one. That is the number divided by the sum of that column times by 100. And that is going to be the percentage. So it's done the percentage for all of those. And again, we can round all of these to make them a little bit nicer. And it's done that by organization code and period. So across is, it looks a bit scary. It's really useful. And the more you use it, the better you'll get at it. It also uses tidy select functions as well, as he says here. So we can mutate across any column that contains ES in the name and do this percentage part and name the new columns something %_ something, the original column name, and do that by organization code and period. So this is what 1, 2, 3, 4, 5 lines of code that's doing a pile of different things. And in pretty much any other coding language that you might have used, this would be a lot longer, a lot more complicated. You do it in separate parts and all the rest of it. We're bundling this all together. It's starting to look a little bit ugly, isn't it? But it's still doing what we want. So the ES columns, the ones that had ES in them, are attendances, breaches. Is it just that, those 2? Attendances and breaches. So we should add 2 new columns on the end. %attendances, %breaches. And it's calculated for us, those percentages. Does everybody get that? It does look ugly and it's a little bit advanced, but it's a snapshot of what you can start doing with mutate and across. If you want to do a similar thing to lots of columns, you can write an across and it actually will pick up either the content of the title or the type or anything else you want. Any questions on that? I realise that one feels a bit yuck. Quite happy? Cool. Right then. All right, row-wise operations. So when we are doing a lot of things in R will automate to thinking you want to do something per column. We can change that to do things per row, to calculate things per row with, funnily enough, the row-wise function, okay? We're going to do a row-wise operation to find the maximum of our attendances, admissions, and our newly created column. In essence, row-wise treats every row as a different group, okay? And we don't feed row-wise any arguments often or usually. So what we're going to do in this first part is we're going to overwrite data work row-wise and create a thing that is a new column that's called maximum column. And it's the maximum attendances, breaches, attendances, admissions, and breaches. Does anybody know what this does? I'll put it at the bottom here. Anyone heard of NA.RM before? Lauren?
Is that the bit that filters it out if it's empty, so it doesn't include empty things?
Yeah, exactly. So there's certain calculations, aren't there, where if there's any NAs in your denominator, the maths doesn't work. Say if you're taking a mean or a median. So with max, it's one of those as well. We don't want, so NA, as I said this morning as well, is treated like a huge number. So if we're taking the maximum of these things, if there's any NAs, which we know is supposed to be an empty thing, those will be treated as the maximum because they're treated under the hood as an infinitely large number. We don't want that because we're not using NA in that way. So we're going to say remove NAs, NA.RM is true. So it will take the maximum, ignoring any rows that are NA in them. So after we do row-wise, we need to ungroup again. Oh yes, it's even said it here. So like we were doing before, when we group and then ungroup, you need to ungroup after row-wise because row-wise is using every row as if it's its own group. Let's run this and have a look at what it looks like. So what we're doing here is we told it to take whichever max call is going to be whichever number is the maximum out of these three rows because we're working row-wise. If we'd said the maximum of attendances, it would have given us the maximum number in this whole column, but we're only looking across the data set at the moment. So the biggest number of these three is 25,000, which is why it's given us that in max call. Similarly with 22, and you can see here that it's ignored this NA that would have been the biggest value had we not said NA.RM is true. That makes sense to everybody. Yeah, Renee got it right as well in the chat. Sorry, I didn't spell that. Okie-doke. Right. We're getting there. Pivoting. Pivoting is, I think, dead easy when you've got used to it. What we're talking about here is changing the shape of your data set to either be long data or long data or wide data. And we'll go through a few examples of this. And I think R is the nicest language to do pivoting in, thanks to Tidyverse. You might disagree with me, that's absolutely right. We often want to convert long data to long data for charts and wide data for tables. So if you've done any plotting in R using ggplot and you're colouring, say, lines by different groupings, okay, ggplot's expecting that data to be in long format. So that's a repetition of some things to make sure that we have everything in a long string. So look at this. We've got a tiny little data set here that's got org, period, and attendances. Okay. So if we wanted this to be in long form, what we would do is we've only got one organization here, but it's repeated 3 times. So if we lengthen that and say the org is only ever ABD, but we take these values of period to be longer. So we've got January, February, and March spread along the way. And for each of those, we have an attendances. Okay, so we've taken this long form into a wide form. We've pivoted it wider. And you can see that if we pivoted it back again, we'd repeat the organization code, which isn't a problem. It's still the same data. It's still telling us the same thing. It's just a different way of structuring the data. And sometimes this is more appropriate. Sometimes this is more appropriate. So it's worthwhile knowing how to do both actions, to pivot wider and to pivot longer. So let's start with filtering our data and selecting only a few columns to make it easier to work with. So we'll create something called data wide. We've got lots of data sets now. We should clean this up in a moment. Which is going to be only the rows, filter as rows, where organization code is RQM, the type is 1, and the period is on or after 1st of August 2018. And after we've taken those rows, we're going to chop off the columns org, code, period, and attendances to only use those 3. So we've got a little tiny wide data set that looks like this. 8 rows long. We've got organization code repeated. We've got different periods, and we've got different numbers of attendances for each of these. Okay, so we've done that. So if we want to create that, pivot it into that wider format, what we can do is use the pivot_wider function. hovering over it, pressing F1 if you want some more information or more examples, which are really nice. And pivoting wider with examples is really, really helpful. And they use the old pipe look. Right. So taking our wide data that we just created, let me get rid of these. We're going to pivot wider, and we're going to take the names from the period column. So we're going to take the different ones in here, and we're going to make them into columns. And under each, we're going to have the attendances. So the values are going to be from attendances. So we've always got a names from and a values from when we're pivoting wider. So let's run this and see how it looks. Tell you what, instead of overwriting it, I'll call it something slightly different so we can see them side by side. So this was what it originally looked like. And because we've pivoted it wider, it now looks like this. The period column has disappeared because we've taken the contents of that and strung it up as different columns for each value that was in it. And the values that we've put for each of those was in the attendances column. Okay, so it's exactly the same data. It's just organized slightly differently. We've got one row per organization code, RQM organization code now. You don't need to remember these. I always forget these, but I do know that names will be in there. And so I'll just put NAM and it will autofill to go, do you mean names from? I'm like, yes, I mean that one, thank you. So can we do the same for breaches? So can you please write me a similar pivot wider from the data wide, but do it based on breaches. So data wide looked like this. Well, data wide will be from breaches instead. So you're going to have the breaches column and then widen that data set out. And give me a thumbs up when you've done it. Does that make sense? I don't understand. 2 minutes to do that. Just going to fill up my water bottle. Anyone want to give me a thumbs up to tell me they've managed to do that? Done. Good. Another few seconds. Share again. Okay, how could we do this then? Well, I gave you a hint earlier on. So let's call it data wide again, which is we'll take data. We'll do the same filtering. Let me just steal this from up here because it's boring watching me type. So we'll we'll do the same filtering, but we're going to do same. So it's the same rows we're going to do, but we're going to select different columns, aren't we? We're going to select org code and period, and this time breaches. If you can't remember how to spell it, just do the first 3 letters. Then we're going to pivot wider. So I'm linking these all in a pipe, right? Bonus points if you use a pipe to link all of them together. Pivot, you see this, these are the versions of pivot you can use. We're going to do pivot wider. And we're going to do names from, and I can never remember if it's names from or names to. So names from, so names for the new columns are going to come from that period column. And the values we want to put in those are going to come from this time the breaches column. Okay. Have a look. So here we've got a similar thing. We've got 1 row per organization code because we've got wide data. And for each entry in the period column, we've now got a number of breaches instead of a number of attendances. Did everybody get to that stage? Everybody happy with that-ish? Any questions on that? Good, you guys are really good at this. We're flying through. Okay. So that's pivoting wider. Let's do a complicated version. Okay, so let's take data, filter the organization code as RF4 this time. We're going to comment out the type because we have not removed the type this time. So we've not specified that we only want type 1 columns. And same date period needs to be on or after the 1st of August 2018. And we'll select those 4 columns. And we've got type in here now, which we didn't have before. So let's create that quickly. Have a quick look. So we've got 4 columns now. We've got the type and everything else. So let's pivot it. So we're going to pivot this wider. So we're going to take the data wider, we're going to overwrite it, and we're going to pivot wider. The names from comes from the period column again. The values from comes from attendances. Okay, this is going to look weird. Okay, so we no longer have 1 row per organization code because we've got another variable in here that we have not pivoted. So we've got types 1, 2, and other. So what it's done quite cleverly is to give us 1 row for each of those, where again the column names are the period because we said names from period, and the values are from attendances, which is what we asked for. So it's kept type as a column. It hasn't pivoted type out because we didn't ask it to. So that's what we would expect doing it this way. So let's do one with more sites. Okay, so this is new syntax to some of you potentially. So the % in % is a nice little base R syntax which says, does this exist within this list? So if the organization code, if the row that we're on, because we're filtering so it's rows, the organization code in that row is in this list of organization codes, we'll keep it. Again, we're not going to bother about type, but we are going to do period. I'm going to have the same 4 columns. So let's have a look at what that looks like. Yeah, so again, from data. So this is data wide. So now we've got 3 lots of this organization code because again, we've got these 3 types that we haven't accounted for in our pivoting. It looks a bit weird for a good reason because this is a very strange way of doing this. But because we've got all 3 of these and we've got all 3 of types that we need to have column-wise as well, we've got quite a lot of duplication going on. So it would be a strange thing to want to do this, but I'm just showing you how you can. Okay, data wide is now going to be the names from period and the values from attendances. So again, we didn't ask it to pivot type, so type still exists. And we've got for each type in each of the organization codes. So you can see in the organization code RQM, there wasn't a type 2. It doesn't, that just didn't happen to exist. So we haven't got a line for RQM type 2. And we've still got, each column is a period entry and each value is to do with the attendances. And so it has summarized these data more widely, but it's a bit more complicated. Don't worry if this is getting confusing for you. You'll have to play about with pivoting before it becomes second nature. If you've done lots in other languages, it might be straightforward for you. But it does get kind of complicated, and you have to think very clearly about what shape you want the data to be in the end. Oh, another complicated version. So This time, we're going to filter and make sure the organisation code is one of these three. And we're going to make sure, again, that the period is after this, on or after this date. And we're going to have all of these variables in. We're going to select all of these. So breaches will be in this data set now as well. So let's look at what that looks like. That's going to be crazy. So we have breaches in here as well. So it doesn't really look like it's pivoted widely there. And that's for good reasons, because we've set this up in a very strange way. Pivot wide. Okay, so now it is a wider data set, but we've got loads of empty space here. And this makes sense because of what we have selected to be included and haven't pivoted. So again, we've pivoted this one. We've got attendances for all of these organization codes based on all of these breaches and all of these types. There aren't always entries for every period for each one of these combinations of things. So this is why we've got a very sparse matrix here of a sparse data set that's not got much data in it. So if your data ends up looking a bit like this, it's probably because you pivoted in a way that doesn't necessarily make sense. It might make sense for some of your use cases. Yeah, yuck, it's not what we want. Let's reset the data again and try again. The data wide is the data set that we're going to pivot, and let's pivot it, names for period, and the values are from a combination this time of attendances and breaches. So wrapped in the combine or concatenate or whatever it stands for. Let's see what that looks like. Ah, that looks nicer. So because we've done this based on the values are from a combination of attendances and breaches, what it's done is it's given us an underscore prefix to each one of the period entries to tell us whether the values that we're looking at are from the attendances or from the breaches column. Go along here, we'll see our breaches columns. So for every value of period, it's given us attendances and breaches, and it's cleverly renamed the columns it's given us to have a prefix that tells us which one is which. And we don't have a pile of NAs going on here, which we had earlier on. Okay. That takes quite a lot getting your head around, but giving the values from a number of different variables will allow you to create that kind of sensible table that renames things. Any questions before I move on? I'm hoping if you started the day going, oh, this is easy, you're starting to go, hang on. Because that's where we want you to get to, right? Stretch brains a wee bit. Okay. Yeah, and as Simon said here, there are options of how to change what the prefix happens to be. If you don't want the prefix to be these, you can specify that if you want to, but it's an extension that you can figure out later on if you want to. Right, so let's do the different type of pivoting then. Let's pivot our data longer. So this time, let's create a data set from data that is just the org code RQM. Again, now we're saying, yes, I only want type 1s. And again, I only want on or after the 1st of August. And we're going to select these 3 columns. So it should be a 3-column data set that we create. Yep, nice little data set. We'll pivot this wider, and then we'll make it long. So let's do it wider based on the first pivot that we did. So the names will be the entries in here, and what will go under those is these values for attendances. Okay, so we've gone back to that 1 row per organization code because we only chose 1 organization code. Then we pivot longer, which surprisingly enough is called pivot longer. With pivot longer, you need to specify which columns is the first argument, and this is used with the cols argument. So we are going to pivot all the columns that are numeric. Remember this where that we had earlier on. So in this, all of the numeric columns, which is all of them except organization code, which is a string, we're going to pivot them longer. The names are not from, the names are going to a column now. So the names of the column that you're creating is going to be period, and the values within that is going to be attendances. So let's have a look at what that looks like. Data long, where's it gone? Data long. So we've gone from this data set that's all wide, gone back into the long form data set. So the values have been gathered up into a column called attendances, and the columns, these, have been gathered up into a variable called period. So we're back to how it looked before, right? So this is the long form of that data set, and we've done it using pivot longer. So yeah, pivoting to longer is a little bit harder because you need to know you need to give it which columns to pivot. What you can do is, if you've got a really long data set and you want to pivot based on loads of columns, you can do the inverse. So you could, as we've seen before, the columns is maybe not C, so minus C, and then put the columns you want to not pivot in there. You'll need to play about with it. And again, F1 is your friend. Go and have a look at pivot longer and look at some of the ways you can do things with pivot longer. It gets very complicated. It doesn't have to be. So this one, they've got a table called Relig Income, and they've pivoted it longer. The columns is just all except religion. They've got a column called religion and they don't want to pivot that one. And they've said the names will go into a column called income and the values will go into a column called whatever that says. I can't go left on here. All right. So pivoting longer is dead useful if you're going to be plotting or doing any of that kind of stuff, because often long data format is what they want. So they want the version that repeats one of the grouping elements because it helps in the syntax for ggplot2 and that kind of thing. Okay, he said, not going to lie, pivoting wide data to longer is hard, it requires much more wrangling. The principle is the same, so we're going to move on. I think he got bored with pivoting. I'm going to pause there though, because the last half hour or so we've done a lot of things. Does anybody want me to go over again anything that we've gone over in the last little section? Does everybody feel like you sort of got a handle on those things or can see how you would make a start with them? Anyone want to ask anything? Cool. Okay. We've done really well. We've gone really far today, actually. What I'm going to suggest is that we take another quick comfort break now. Let's say 10 minutes. If we come back at 12:10, and then we'll see what we can get done. We're going to be picking this script up again tomorrow to do the next part of it. So whatever we manage to get done today will be earlier finishing tomorrow, unless we want to go back over plenty of things. So give me a thumbs up if you're all right for a 10-minute break now, if that's long enough. If you're happy to do that. Yeah, like most people. Brilliant. Okay. Right, guys. See you back here at 12:10 then. Thank you. Hi, folks. I'll just leave it till 10 past exactly to make sure people can have time to get back with a cup of tea. Oh, there it is. Okay. Home stretch. We're nearly there for today. I've got you till 1 o'clock, so we could do another few little bits, but we'll take it easy. Hopefully it's all going okay on your end. Again, you're a very quiet group, so I'm guessing that's a good thing, but if it's not, let me know. Right, let's pick up where we left off then. So we're up to line 866 in this script. So we're going to look at some rolling functions. So that rolling functions are a really common thing to use particularly when you're doing any kind of epidemiology and you've got a time series and you want to know what the average of some chunk of time was and how it changes. So let's say we wanted to find out what the 6-month rolling mean of attendances in our AE attendances dataset was for each site in our dataset. So the zoo library is a little library that's dead useful and can handle these things quite nicely. I haven't installed it yet, so if you haven't as well, let's install it. Last time I installed packages by writing install.packages. Let's do it a different way just to show you that you can. So if you go into the packages pane, we can click install, and here I'll just type zoo and install, and it does exactly the same thing as if you had typed it in. There, zoo's only a tiny package, so it should be dead easy to install. And then we need to load it using the library function. And again, we've got a number of masking messages here, like we talked about before. So from base, the base as date and as date numeric functions have now been masked because zoo has its own versions of those. So if we write as.date, we're going to be using the zoo version. Okay. I don't think we need to worry about that too much. Let's reload our AE attendances data just to make sure that we've cleaned out all the nonsense we did before. And let's do a little bit of a filter. So we're going to take the data, we're going to take the rows where the organization code is in, remember, %, one of these. And then we're going to arrange the data. We haven't talked about arrange yet, but it's another useful, does what it says in the tin function from dplyr. We're going to arrange it by organization code, and then within that type, and then within that period. Then we're going to create a new function called rolling, called rolling. And what we'll use is the roll apply function from the zoo package. So roll apply, you can see there that I was about to point with my finger. You see there it takes data as its first argument. When we're in a pipe, it's assuming that the data you started with is this argument, so you don't have to say it again. So we're going to be applying a rolling function to the attendances column. The period over which we want to roll is 6 months, and the value is the mean. Let me just F1 this because it'll make sense to show you. So yeah, so that we've get data has already been piped in, so we don't need to specify again that we're using the data set called data. A numeric vector or list is an integer specifying the window width. So here we put 6, and because it's a monthly data set, we're saying 6 months of it. The function is the function to be applied, which in this case we want the mean. And aligning, this is if you want to take the mean of only dates that happen before the index date. You can have it left aligned as well. I don't know why you'd want to do that necessarily because time moves forward. But if you don't specify a line, I think it will it automate to right? Specifies, yeah, so it's centered is the default. So if you don't specify a line is right, when you're looking at a date here, it will take the mean of 3 months before that and 3 months after that. And all of those it'll take the mean of for that particular date. Now, with time series, it doesn't usually make sense to do that because the average of this this variable, what you're actually asking about is historically what has the average been in the 6 months beforehand. So you want to right align it rather than have it centered. That may not make sense to you. Apologies if not. And we're going to fill equals na. And so fill is a 3-component vector or list providing filling values. So where we haven't yet got 6 whole months, what are we going to put in there? And we're going to put NA in there. So we're going to do all of this again by a combination of 2 different variables, the organization code and the type. So this is a great big long pipes thing. Hopefully all of it is understandable. Let's run it and see what it says. So data roll is what we've got. Data roll. So we've now got a rolling column that we asked for, and it starts off with 5 different rows of NA because for this particular date, we don't have 6 months before it, so it can't calculate the rolling average. So it's got NA, filled in NA where it can't. And then where we do start having, on the 6th one, was it admissions we did it over? It was attendances. So it's looking at these 6 attendances and doing the average of them here for this row, okay? Then for each of these, it's looking back 6 months, 6 rows to the previous element. We've organized it by period and organization code and type. So we can do this. So that gives us a rolling mean of the previous 6 months worth of attendances. Relatively easily. Hopefully that does look relatively easy. Does that make sense to everybody? And can you see how you would easily change this to be the rolling median or the rolling for 3 months or whatever it is? I'm hoping that how you would modify this to suit your needs could be quite easy. This is set out kind of strangely over lots of lines. We didn't need to do it like this. So let's just make it a little bit less ugly. Actually, no, maybe let's not. How you set it out is up to you entirely. It's still going to be not covering this line. It's not going to go over this line, but it's not as easy to read the more you split it. So that's our rolling means, okay? And because it looks relatively simple as to how you can specify what you want to roll over, we're going to immediately ask you to do something then. So see if you can change the window that you're using to calculate the mean to just 3 months. Add a new column with a median over 3 months. With the median, see if you can calculate it on the middle time period and replace any blanks, with quadruple 9. So that's lots of different changes. I'll give you 3 or 4 minutes to see if you can do all of this. Have a go. It's quite challenging, but I think you can manage based on just this bit of code here. Any questions before we start that? Okay, have a go. I'll be here if questions come up in the meantime. As usual, give me a thumbs up if you've managed to get there. Can't remember when I started this over to you section, so I know a few people are done. All done, Mark, Danielle, Jenna, Benjamin, and Sabrina. Lauren.
This is not a question about the task, but it's more just a general thing. I find sometimes with our studio that if I've got my data set open and kind of a tab at the top, sometimes it's really good at refreshing when I've repeated my code and overwritten it, and other times it doesn't. Is there a quick way to refresh it other than just closing it and reopening it? Because, you know, you look at it and go, oh, that's not right.
Yeah, it trips you up. Yeah, if you're expecting it to refresh and it hasn't, it can trip you up, doesn't it? I've not come across that myself. It tends to be quite responsive. Is it when you're using it in the cloud, or was it when you're using it locally, or both?
Locally, I think.
It might be something to do with your system, although it should, if you overwrite the data frame as it's called at that time, it should overwrite within the view. But yeah, I would just close it and open it. It's probably the safest way to do it. Because then you're forcing the issue a little bit. Yeah, I don't think there's an easier way necessarily.
Okay, thank you.
No worries. Right, hopefully everybody managed to do that. Let's have a look at. So we're going to start doing the same thing, aren't we? We're going to have the same filtering, so the same rows we're going to work with, and the same columns we're going to work with.
Sharing again.
That's 3. If I get to 5, what happens? Well done for telling me. Sorry. Okay, try again. So I've copied and pasted the first bits, the filtering and the arranging, because they're not going to change. These bits might. Okay, so let's pop them down here as they were. So what did we want? We wanted a 3-month window. So we're still working with the attendances column. So we're going to have a 3-month window. We wanted it to be median, which is as easy as that, because median is obviously a well-used word within R. We're going to align it center instead this time, because we don't want it to take the 6 months previous to the current row. We want it to take the 3 months before and 3 months after. So center. And we're not going to fill it with NAs this time. We're going to fill it with 9s. So we can just do this. And that should give us what we want. Let me double check that that is what I thought it was. Okay. So now we've got a slightly different setup here. And we can see that this is the first value, because we'd said if we don't have yet 3 lines worth to do a median of, well, actually 1 line worth, because for this row, what we'd want is the one before and the one after it. So the attendances before and after. We don't have an attendances before it. So we can't do the average for this row. So we've given it quadruple 9. In reality, this is probably a bad thing to do, because these real numbers that we're calculating here are not desperately different to this. So you might get confused if you did it with treble 9, but it's up to you. And then we've got our rolling median here. And medians, remember, are a middle value. So they shouldn't be long decimal places and that kind of thing. So that seems to have worked. Did everybody manage that all right? It is a little bit nuanced. Any other questions on it? Okay, next part then, row numbers and date manipulation. We mentioned earlier that dates are a pain in the neck, as you'll see. So adding in a row number is useful for calculating times between things or identifying things like referral time to second contact. So again, a lot of time-based elements in our data can trip us up if we don't know how to work with them quite sensibly. So I'm going to create a new column now that is just the row number. And funnily enough, you can just pass row number brackets into the mutate function to create a row number column. So let's do that now, and I'll just show you. Here we've got something called data row, and we've got a row number column, which just is the row number that you're on. So these are the same as these row numbers that R gives you when you're viewing data. These are not part of your data frame. They're just an identifier of where you are, essentially. But we've used them as a new column now by just passing the mutate row number. Okay, so again, we've filtered, we've arranged, and then we've created a new variable using mutate, which is just the row number. If we want to do a row number per organization, say we wanted to see it per org code, then we could, again, as we know already, add the .by argument to the mutate column. We'll do .by and by org code and type. So if we do that, then we're going to start counting here, and then we're going to see we're not going to get very far up until we restart, because we've got a new organization code and a new type. Well, the type's the same in this instance, but every time we change organization code or type, we're going to start the count again. So it's the row number within that grouping of those two variables, organization code and type, which is just a very useful little thing to know, essentially. A row number per date. It's called dense rank. I don't know anything about dense rank. Let's see what it says. So it's a dplyr. Also, it's a type of, it works like minimum rank, but doesn't leave any gaps, so that the combination of 10, 20, 30, 10, 20, 20, 30 gets ranks 1, 2, 2, 3. Okay, so it's ranking the period number instead. Let's see what it looks like. So this will be the first period within that organization code, I think. Does that make sense? Yeah, so within organization code RQM, we've got the same period twice. So they're both the first because it's the same one twice. If we arrange this by this, so I've just clicked organization code. When you're in the viewer, you can click on any one of the column titles here and it'll rearrange just on the fly, not in the actual data, but on the fly, it'll rearrange the columns for you. So we can see we've got all these different periods for the organization code RDD, and they're numbered based on that. So they're numbered based on the ordered period within the RDD code. So we go to the next one, it should start again. Yeah, okay. And again, we've got the same period 3 times with RJ1, so it'll still be ranked number 1. So that's what dense rank is doing. You can read through these if it's difficult to understand, because it is doing something quite subtly different. It does things with ties if you've got tiebreakers and whatnot. That may be of use to you. So we can do a row number per date using dense rank, but in the reverse order. So we would usually do a minus to reverse something, be it a numeric or whatnot. And it would invert it. However, we can't invert a date. It doesn't make sense to R to do that. So we have to reorder them and then convert the rank into an absolute value, which is horrible, but it works. Okay, so the only reason he's put this here because somebody asked him to put this here. It is horrible. So what this is saying is create the data row object with the data object that we already have. Select the rows where the organization code is one of these 3. Then make a new column on it called row number. And row number is going to be the absolute value. So absolute takes off a negative. So if you've got minus numbers and you write absolute, it'll just be the number without the negative on it. Absolute descending value of the dense rank of period. That's gross, but I'm sure it works. Yeah, so it is descending now, and it is the absolute value, so it won't have negatives in it. Goodness knows why you'd want to do that, but hey ho, there we are. So I've shown you abs and desk as well, based on dense rank. And they work in other places. Obviously, descending can work on numbers. It can work on, if you give it a vector of strings, it'll arrange them in descending order of the alphabet, etc. So, and like I said, absolute is an absolute value, so it should only work on numeric elements. Okay. Row number per date, jumping the missing. So this is part of min rank. So min rank gives every tie the same smallest value, so that if you had this combination 10, 20, 20, 30, it gets the ranks 1, 2, 2, and 4. It's the way ranks are usually computed in sports and is equivalent to the rank. If there's a tie, use the minimum. Does that make sense to everybody? I don't do much with ranks. Ranks I find quite difficult to understand, but you guys might find it a lot easier. So what we're doing here is we're creating the row number column, which is going to be the min rank of period. So instead of doing the dense rank, without leaving gaps. So in dense rank, remember, it would be 1, 2, 2, 3. So because the middle 2 are the same value, it's ordering it by lowest to highest. So this will be number 1. These 2 will both be number 2, and this will be number 3. Whereas in min rank, it's doing it by element number. So the first element is the 10. Second element is tied with the third element, and then it skips number 3 and goes to 4 because we've got 4 elements here. Hopefully that makes sense to you. Don't actually explain it again, it's very complicated. So that's what we're doing here. We are jumping over essentially the unused third element if it exists. Does that make sense? Okay. So now we're going to remove 2018 and check the row numbers still work on the new data set. Okay, so taking data row is data, filter where the organization code is one of these. And we're also filtering to have rows that are not between period. So they're not between the values of period that are this and this. Okay. The exclamation point means not, and we haven't used between yet, but you can imagine what it does. Using the column period, we don't want rows that are between the 1st of 2018 and the end, the 31st of December 2018. We pass these in as an as date, which is a function that we've got in base and in loop_date. And we have this syntax here as date. And the reason we do that is because if we just pass it this, it would get confused thinking we were talking about a string because we've got it in speech marks. And if we just do it as numbers, it'll get very confused. So we have to specify that it's a date. So we wrap the date in the brackets and have them in speech marks within. Then we're going to do these other things, get the row numbers, etc., etc. So this is what it should look like if you followed along with that. So we shouldn't have any 2018 dates in here now. And we can use this tip I showed you just now to click on period, click it again, and it'll go from highest to lowest. So if we go backwards, we can see we skip straight from 2019 to 2017. There isn't a 2018 in here anymore because we said we don't want those rows that have a date between those two dates. So he says the exclamation is awesome. For example, could add it in front of the organization code to filter everything except for those organization codes. And we've shown you today a few different ways of using the exclamation mark. You can try it out in various different ways. It always goes before the function. So let's see if you can adjust the code above to remove the year 2017 and return only the first 3 rows for only type 1 for each organization. That's horrible. I'm sorry. Have a go with that. See how you get on. I'll give you 3 or 4 minutes to do that. I'll keep sharing this screen so you can see this as well. Everybody understand the question? Everyone understand the task? Oh, okay, have a go. Give you 3 or 4 minutes. Everyone manage that okay? Anyone struggling?
I'm not there yet.
I'll give you a minute. Right, is that challenging? It may have been dead straightforward for you. So what we're going to do is we're going to modify this great big function we've got here starting on line 980 to address the questions here. So we're still going to filter the same organization codes. We're not going to filter the same date though. So the easiest way to do this would just be to change this to 2017 because it's still the 1st of the 1st to the 31st of the 12th is the date period that we would like to have. And we also want to filter it for the first 3 rows. So we can add, after the mutate, we'll add a filter. Am I sharing my screen? Yes. Yes. So because we've got row number as a variable, we can filter that row number is less than or equal to 3. We can also filter that, what was it called again? The type. Type is it? It's one of those. Let's see if that works. So how did everybody get on? So you see, we've taken this, we changed the date that we wanted to see, the date range that we wanted to see, ever so slightly to make it 2017. And we filtered to make sure the row number is less than or equal to 3. So rows 1, 2, and 3. And that the type is only type 1. We've got type 1 here. We've got the first 3 rows of each organization. And we've got the row number going 1, 2, 3. Is that what you all got? Is that what everybody got? Something approaching that. Cool. Well done, those that did. Awesome. You guys are too good. This stuff takes longer usually. Right, what are we on? 22. I wonder whether we'd be better stopping today and starting with dates tomorrow. We started doing a little bit of dates today, passing in the as date function, but I think it might be a nice place to stop for today to start doing dates tomorrow. Dates have got a lot to them, and you might want to bring your particular issues that you have with dates locally, and we can talk about those in the morning rather than us try and bosh it out now in the last 20 minutes. Is that all right? Does anybody heartbroken that we're not going to do dates now? Anyone got any questions as well about anything we've covered so far today? You've been very quiet, which is hopefully a good thing. You never know. Okay, well, again, you can put messages in the chat again after the meeting as well. What we'll do then is I'll give you 20 minutes of your afternoon back, and we will reconvene 9 o'clock tomorrow, and we'll start off from about line, what's it, 1025 tomorrow, so that we can have a look at dates. Feel free before now and then, if you have time, to go back over the stuff we've done and apply some of these functions and these methods to your own data to make sure that you are understanding what it's doing and getting that repetition in there for the muscle memory. It's not muscle memory, it's just memory, but you know what I mean. Okay, right. If no complaints then, thanks very much, guys. Well done. It's a lot to take in today, and we'll start off tomorrow at 9 o'clock. We'll see you then. Thanks, guys. Bye.